Python is the backbone of AI data engineering domain, but Python basics are not enough. That is why this 4 hours long advanced Python course will cover all those areas which are actually relevant in the modern AI data engineering world, such as multithreading and multiprocessing, asynchronous framework for Python, inheriting and importing customized classes and objects, data validation, data checks and data parsing with Pydantic, fetching data from APIs with dynamic pagination, working with Delta Lake using Python libraries, and much more. These are the topics that you need to master in 2025 because these are new, plus relevant, plus in demand in the world of AI data engineering, especially in 2025. And do you know what? After completing this video, you will be able to understand plus confidently work with the modern frameworks that are available right now. Just a reminder, hit that subscribe button right now so that you will be receiving all the valuable tutorials which will help you grow in the modern world. And let's get started with this amazing masterclass. So what's up my fam? Happy Sunday and happiest Sunday this time, bro. So as you can see, as you have already seen, today's video, okay, Python for AI data engineering. Let me just tell you in very brief, like what we're gonna cover in this particular video. See, I know that you know Python. What Python? Very basics. Let's say loops, functions, variables, all those basic stuff. I know that you know all those fundamental knowledge because you would have covered Python in your school, college, blah 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 blah. I don't know, but you know Python. But do you know what? That Python is just the fundamental area. It's just the base, which is very important, but that is just the base. When you need to develop something, and I'm talking about AI data engineering, okay? Yes, AI data engineering. Now, if you are not a data engineer, if you are not actually from the data domain, bro, hold on. This video is still for you because Python, or let's say whenever you just talk about AI world, data engineering is the area where you can manage the workflows better. So even if you are not a data engineer, this video is for you. So don't worry at all. But I love my data engineers. I love my data family, data community. So that's why AI data engineering. So this video is actually one of the best videos for AI data engineering world. Why? In this particular video, we are covering much more than those fundamentals. I have already created one video on Python fundamentals, Python basics. If you have watched this video, you can just continue with this video because I expect that you have some basic knowledge. You have some fundamental knowledge because this is advanced Python. This is not just like very basics of Python in which I'm just telling you, hey, how to create a variable, how to write a basic loop. No, you need to cover those fundamentals on your own through my video or through any content, through any resource. That is up to you. But yes, I have created a detailed video on Python fundamentals. Simply go on Google, simply search. I will just attach the link in the I button as well. Python for fundamentals or blah, blah, blah. So that will cover your fundamentals. But Python for AI data engineering, we gonna talk about some amazing areas which are a little bit of hidden, plus new, plus complex, plus so many things. Just to give you a hint so that you will feel relevant. Okay, obviously you would have watched the introduction and you would know the areas that we're gonna cover. Pydantic, asynchronous functions, multi-threading, API calls, all those things. We gonna cover all those things in this particular video. Okay, and I would say I do not expect any kind of knowledge in those advanced concepts, but I expect that basic fundamental knowledge from you so that you can just continue with this video. Make sense? And trust me, after completing this video, you will be able to understand all those slangs, all those concepts that are floating right now in the world of AI data engineering. Everyone is using API wrappers, API calls, all those LLMs. You will understand what's going on and you will understand how to use those things. Like obviously just from the Python perspective, there are like so many areas, like that is obviously a different domain in itself. But yes, once you complete this video, Python for AI data engineering, you can literally feel relevant with the concepts, with the slangs, with the jargons, everything, whatever we have in the world of AI data engineering. Are you excited? Are you excited? If yes, drop a comment on this particular video right now. See, I'm not just saying for the sake of getting more comments. The thing is, I want to help maximum number of people through this video. And Literally, trust me, this is a masterpiece video because I have already completed the recording. I'm just shooting this introduction after that. Amazing masterpiece, amazing demonstration in the form of chapters. And I want to help maximum number of people so that they can also grow in their career, and obviously they can just bring a nice smile on the faces of their loved ones or their family members or anyone. So just drop a comment because your one comment actually will help this to grow this channel a lot. That one like button, one share button, one comment will actually help me a lot. And I personally feel very happy when I just read your comments. So just go ahead and just show your love and let's get started with this. So let's get started with our amazing masterpiece. And as I just mentioned in the introduction as well, okay, so now we are just getting started with it. Just for the environment setup, as this is an advanced Python course, or you can say video or tutorial masterclass, whatever you want to say, I would expect that you know how to install Python on your system. And I would expect that you know how to install VS Code on your system. Can I expect this basic thing from you? If yes, very good. If you do not know how to set up Python and VS Code, it's fine. It's fine. It's fine. Okay. There are like so many resources available, like how to install Python. Nothing to do. Just go to the, you can say, any browser, just search install Python and just download the latest version of Python. It will be, I think, 3.13. Then that is done. Then simply download this VS Code editor. If you have anything else, let's say PyCharm or whatever, it's fine. It's your call, whatever IDE you want to use. You can also use Anaconda, Jupyter, whatever. But I'm just using VS Code for this one. And if you just want to set up, it's very simple. Simply download the VS Code and that's it. There's one very handy extension that I can just mention. Simply click on this button and this bar can be here. Okay, in your case, and it's fine. I'm using some themes and customizations and all. So I can simply click on extensions and you can simply search Python. Okay. So this is the extension that you can download, not debugger, just Python. So basically this is the extension that will help you in the IntelliSense as well. And in this particular slang, we call it as PyLance, which is like IntelliSense for Python, which will help you in code completion and all. But trust me, nowadays these are like all replaced by this GitHub Copilot. Okay, so it's up to you, whatever you want to use. So this is like basic setup that I am expecting from you to set it up. Okay, because obviously I don't want to just tell, hey, how to download Python, how to just download VS Code and how to set it up, and like very basic stuff, right? So you can, I am expecting this thing from you, okay? Because obviously this video is an advanced Python course, so I would expect some knowledge from you. Okay, so now let me just tell you so far what I have done. You will be seeing Python Advanced. What is this? I have simply created a folder in my C drive and I have simply opened that folder, and this is an empty folder. See, nothing is there. And you can also do that, go to file and then click on open folder, and you can simply pick your folder. Okay, you can even create new at the same moment, or you can create a new folder beforehand and then you can just open it. So far so good, very good. Okay, finally, I hope that it was very simple. Okay, so now what we're gonna do, we will get started with our first chapter of this particular advanced, you can say, because I want to just split this video masterclass in the form of chapters. Okay, very good. First of all, and I am expecting you that you have some basic knowledge, as I've just mentioned in the introduction as well, but just repeating because it is like common sense. Okay, if you do not have, let's say, fundamental knowledge, I would again highlight this video because this is a masterpiece. Simply go to, let's say, Google or any browser, simply search Python full course, basically for data engineers, and simply add Anshlamba and you will find the video. See, this is a 6 hours video in which I have mentioned, I think, everything from scratch, like spoon feeding, like what is a variable, what is Python interpreter, everything. So this is like complete guide for you if you just want to get started with Python, if you do not have any knowledge. Okay, so I'm expecting you that you have just watched this video. Even if you do not have watched this video, I would expect that you have some knowledge, let's say very basic knowledge. Okay, so enough prerequisites are discussed, because every time people ask, hey, what is the prerequisite for this video? And I don't know, like, if they even watch the introduction part, because in every video I make sure that I am just discussing the prerequisites, right? I'm so possessive for you. Possessive? You can't be possessive, Anshlamba. Why? I am possessive. Okay, so now let's get started. Let's create our first chapter. It's called chapter 1, classes. Okay, Anshlamba, classes. Don't worry, this is not like a complete guide on classes, because classes we have already discussed in our previous video, which is like fundamentals, because classes is a very basic thing. But the thing is, all the advanced concepts are built on top of classes. Not all, most of the concepts. Okay, and it will be a just quick recap. I know you are ultra pro max Python developer, you know everything. Okay, so this is just like a quick recap, and it will be very handy for those who do not use classes frequently. Okay, because classes is kind of a concept which also gets fit in the fundamentals and in the advanced courses. This is like a baseline, or you can say this is a borderline between basics and advanced. So I have to touch this baseline, I have to touch this borderline in order to just explain the things in a better way. Okay, perfect. And I hope you will just enjoy this classes quick recap. Okay, if you do not know, it will be a like amazing guide for you. So within this folder, I want to create a file. Okay, let's say I want to create a file called first class. Firstclass.py. Okay, perfect. And don't worry, I'm just using here themes for icons, themes for texts. In your case, it can be different. Don't worry about that. If you want to also use themes, you can go to extension and simply search some amazing themes that are available. Okay, sorted. So first of all, let's talk about classes. Now, what are classes? If I ask you, hey, you create Python classes, what is actually a class? To me, like, classes can be defined in one line. Classes can be defined in one page, or even let's say in one chapter as well, because classes are like classes. Simple and sorted, classes are like the bundles. Bundles? Yes. So for example, you are building something. It can be an application, it can be any pipeline code, anything. Okay. Why pipeline code? Because like I'm so connected with data engineers. Okay. So let's say you are building something, and in your code, you have so many functions. Okay. You have so many variables. Okay. You have so many things. Okay. So classes help us to group together the related stuff. I think in a data world, I can relate it with the clusters. So it's like a cluster. Class is like a cluster where you can just group together the similar things, the related things. What is the benefit of it? Because we would know, let's say you are writing a code for, let's say, bronze layer. Now, what is a bronze layer? If you're not a data engineer or not a data guy, basically, we work in a medallion architecture. Okay, let's forget about this example. You will be like, hey, what is a bronze layer? Okay, so let's say you are writing a code for a game. Okay, and this is like a 2-player game, 1v1. Okay, so you want to create all the moves like punch and all those things, right? So you would like to create all the functions for the same. Sorted. Now you have a second player as well, and you have all his moves or her moves. Okay, and they can be like so many players, right? So many characters. So will you be like creating so many functions and there's no grouping, there's nothing, and it can be so confusing. So what you can do, you can simply create a class for each player. You can simply say, hey, this is the class player, let's say XYZ, and you can store all the variables, all the functions, and all the related stuff within that class. What will be the benefit of it? Just bundling, just collection? Not really. This is like one aspect of it. Second thing is we can reuse all those things. We can create instances, that is also called object. We can create objects. That is why it is called object-oriented programming. We can define a class and we can create multiple objects within that. Make sense? Okay. So very common example, let's say I'm building a class. Let me just increase the text size. Okay. Class, let's say first class. So class can be, let's say, my class, or let's say class employee. This is like very common example. Everyone builds class employee as it's his or her first class, I'm so sure. Okay, let's pick another one. Let's say class, let's say LLMs, basically LLMs. Okay, LLMs are like large language models, and these are like very popular terms right now. Okay, so let's say this is my class, and let me just snooze this code suggester for 5 minutes. Oh, 70% are done. Oh man. Okay, class LLMs. So now I mentioned that we can just store our variables, our functions, our all those things, but we have some fancy names for functions and variables. Yeah. So for functions, we call them as methods in the world of classes and objects. Functions are equivalent to methods, and variables are equivalent to attributes. Make sense? Attributes and methods, and there we have functions and variables. Simple. Make sense? Simple, sorted. Just naming convention, that's it. So now let's say I want to create some variables which will be same throughout the class. Let's say I want to say token size. Okay. Let's say I want to say token size. For all the LLMs, token size will remain the same, and it is like, let's say 100. I know it is very small, but you can, okay, 100 million. Okay, now it's not small. So this is token size. This is one variable. Then you can say who adds comma after the variable? Okay, token size equals to 100. After that you can say okay, just token size. After that you need to create some functions. Okay, function number one, let's say I want to create a function for OpenAI. Okay, I'll write like this, OpenAI. Okay, so this is my function. I will write the code, don't worry. Then I have another function which is called, let's say, Claude. Okay, and then pass. Then we have, oh man, then we have one more function. It is called, let's say, Llama. Let's pick some local LLMs as well. Llama. It is built by Meta, I guess. Yep. So these are the three LLMs that we have. Make sense? Very good. Now the special thing about classes is we always pass a variable called self. Do you know the reason about it? Like self. We every time pass self. Yes, there are some scenarios where we do not pass self command in the functions, and I think they are when we just need to create some methods which are not referring the data or any kind of, you can say, content, not content like variables or functions within the class. So why do we use those functions? Those functions or those methods are just used, let's say I want to create some custom functions, and let's not go like into that particular thing. Let's be very generic. Okay, so let's say these are the three functions, and why we pass self function. Basically, whenever we want to create an instance or basically an object for these functions, okay, and I will just show you, don't worry, we pass the object itself in the self, because this function will be different for each object, right? So whenever we'll say self, so self is like we are passing the object as well within that. Oh, so that is why we write self. Make sense? So these are three functions. We have OpenAI, Claude, and Llama. Okay, and let's create a very simple statement. Let's say I'm printing something. This will say I am OpenAI. Okay, this will say, don't worry bro, we gonna write amazing complex code as well. Do not feel like, hey, I'm just writing print statement. I am Claude. Okay, and this will say print I am Llama. O Llama or Llama. Okay, I just call it as Llama. If you just want to say O Llama, you can just add O here, O Llama, but Llama is cool. Okay, so I am Llama. So these are the functions, basically methods. Make sense? So these are the functions that we create. So now let's say this is my class and it is done. If I want to create an object for this particular class, I will simply say LLM object, or basically object equals, or let's say object 1. Okay, object 1 equals LLMs. Okay, perfect. And there is no dependency on the variable because we do not have any kind of variable that we need to ask from the user, and that's it. And now if I want to use any function, I will simply say object 1 dot function name. It is OpenAI. So if I just use this function, and this will be a very quick guide for you. That's why I'm just picking some AI examples, because nowadays you are seeing that people are just using some frameworks for OpenAI functions and all those REST APIs, all those classes. So they have already built the classes for you that I will just show you. Don't worry at all. So they are basically using the classes which are built by those big companies, big LLM providers, basically managed services that they have. So they're using these functions from those particular classes. Make sense? You would be just using something like this from blah blah blah. So this is the way that you are using this thing. Make sense? So now you will be just feeling relevant. Okay, and you will be just feeling like, okay, this is the code that would be created behind the scenes. You are not simply copy and pasting the code from the documentation or API reference. Okay, you need to understand what's going on. Okay, sorted. So if I run this code, just click on this debug button, or even if you can just open the terminal as well, simply click on these three dots, go to terminal and new terminal. Okay, so you can also run this command in this particular thing. It's python first class .py. It is saying no such file or directory. Oh, I just need to use those python -m blah blah blah, and you can simply click on debug. For now we're gonna cover those commands as well, don't worry, because I personally prefer using UV instead of these outdated commands. What is UV? If you do not know about UV, I can just give you a quick guide for UV as well, don't worry. So as you can see that I have got the result for this particular, you can say, function that we have used from the class. Make sense? Okay, very good. Now what we're gonna do, I will just simply quickly show you something that, let's say we're gonna take some variables from the user. What we can do in that particular scenario? Okay, in that particular scenario you have two options. First is you can simply say, like, you can just define some variables in the function itself. Let's say you want to use some function here, let's say any kind of variable in these functions. You can obviously use the variables here, but ideally you should ask for the variables in the class object itself. So we use a constructor. Constructor is a very fancy name, and what constructor does, it constructs the class variables for you. So for example, how does it look like? Let me show you. Def init. Okay, then you need to simply say self. That's it. Now within this particular function, it is turned on again. Let me snooze it for one more time. Okay, so self. Now if I write any variable name, let's say I want to pass what do I need to pass? Let's say query, because obviously if I just want to use OpenAI, Claude, Llama, I want to just get the input from the user, right? Whatever their question is, let's say query. Okay, so now what will happen? This function, let me just say self.query equals query. Now what just happened? Let me just tell you. So the biggest advantage of this particular function is this function will be automatically triggered. Oh man, this will be automatically triggered whenever we create any instance. For example, if I write something like this, let's say object equals LLMs. If I run this command, this will automatically trigger this function. So we can leverage this function to define our variable like this. Okay, and now if I run this thing, this will throw me an error. Why? Because now I need to pass this variable as well. So now I will say, hey, who is Anshlambacollab? I know he is amazing, but just tell me an answer or give me an answer. Okay, so if you just want to ask this thing from your LLM, I'm feeling like I'm just teaching you those things. Okay, so now if I just pass this thing, if I just run this now, this will simply say, okay, this will create this object. That is fine. So that means now I can use this particular variable in my functions, and there's a special way to use it. How? You need to use this particular function using this particular, you can say, way of writing it. It's called self.query. Why? Because you want to if you want to use any variable, just forget about this thing. Even if you just want to use token size variable as well, you have to use self keyword before any, you can say, variable or function, because you are referencing its own objects. Okay, so you will simply say self.query. So I can simply say I am OpenAI, and if let's say you want to return some dynamic content, you will say, hi, I'm OpenAI. You asked self.query. Make sense? Okay. Makes sense. Makes sense. So if I run this now, what will happen? What will happen? If I call this function, I will simply say obj.openAI. Okay, makes sense. Now you will be feeling like why I'm covering these classes, because now you are understanding what is actually going on behind those API calls that you may be making in future if you want to learn AI, and also now you will be feeling connected with those things, with those code. Make sense? Say thanks in the comments. Saying thanks to someone who is helping you is a good habit. Okay. So simply run this code and now you are seeing the response. Hey, I'm OpenAI, and you asked, hey, who is Anshlamba? I know he's amazing, but just give me an answer. So this is the way that you can just reference these things. Make sense? Very good. So now let's cover the last topic of this classes, which is called inheritance. Because I was waiting for this moment, because inheritance is something that will make you understand the advanced concept that we're gonna cover. Okay. Now, a lot of people just feel very awkward whenever we just talk about inheritance, because they feel like, oh, what is inheritance and all. It is very simple. Let me just tell you. So let me just create a new class. Okay. And we're gonna create inheritance in using a real world scenario, like how actually we just use inheritance. Okay. So usually if I just want to give you a tutorial, I will simply say, hey, just create a class here, second class, just inherit it, blah, blah, blah. No, ideally we do not do that, because you will be writing, let's say, 1,000 lines of code for just one class, at least 100. Okay, good. You will not be liking to create another class within the same file, right? So how you can just perform those things? How does that work? So let me just tell you what you need to do. You will be creating a second Python file. Okay, you will simply say inherit class.py. Okay, so we already know that we have this class called LLMs. Now you want to create another class. It will be like, let's say, what class we can create from LLM? Let's say chatbot. Let's say you want to create a class called chatbot. Okay, and within this class, okay, you want to import all these models that you have here, because obviously you would not like to first of all snooze. You would not like to, let's say, and let me just add 5 more minutes. Let me add 5 more minutes. Yep, very good. So let's say you want to create a class called chatbot, and you would not like to, let's say, write the whole code again for these particular functions. Make sense? You can copy paste, but you do not do it in the real world, right? So what you do in the real world? What? So basically in that particular scenario, you will simply say class chatbot, and you want to now inherit this class. Which class? It is called LLMs. So you will simply write LLMs. Simple. But here it will give you an error. See the blue line. Why? Because it doesn't know like where are the LLMs, like basically where is the class called LLMs. Now you will import the class. How you can just import the class? You will simply say from, and you can simply define the path for this particular file, and you will, let's say, path. Okay, from path, and you will simply say import LLMs. I will just give you the path, don't worry. So this is the way you can import this particular class LLMs, and now you can write LLMs. See, error is gone. Now error is gone, because now it knows that you have just imported this LLMs, and now we need to just correct this. Make sense? Very good. So now in order to give the path, you just need to refer the path from the current file. So current file is this one. What is the path? If I just say, if I want to go to this particular file, okay, so we can just use a relative path. Make sense? If I just click here, and if I just right click on it, and if I just click here, copy relative path, if I just paste it here, what I will get? Just this file, right? Because this is a relative path for this particular file. So I can simply say from first class import LLMs. Make sense? See, now it is blue. That means it has just got the this particular class. Okay, makes sense. And now I can just use everything that we have inside this class. Make sure you remove everything, print command and blah blah blah, because what happens whenever we just import anything, Import means it will run this file and it will attach this file into this particular file. Let me repeat. It will run this file and it will attach this file in this particular file. Makes sense. So you will say anshlambacollab. Okay, we will just remove that print command and all. But what if we just want to save it? Because obviously we want to just write some print command for our testing. So for that particular purpose, we simply write something called as if underscore underscore name underscore underscore equals to underscore underscore main underscore underscore. If I just write any code here, let's say print anything, let's say I'm creating an object here in this class, LLMs, ansh. Okay. And then you are saying print obj dot OpenAI. Okay, perfect. If I just run this command now, and in order to run this command, obviously you can just debug it. So what will happen? Now it will just return this thing. But now this command will not be merged in your code. Let's say here. Why? Because you are saying just run this code if you are running this command, basically this one, basically this file from the main function. Main is the file which is the original file. So this code will only be executed if this particular function or anything within this particular, you can say, block is executed through the original file, but not through the inherited file or any other file. Make sense? Make sense? Okay, very good. So let's create some more functions here. Let's say I want to create def init, and then let me snooze it. Okay, perfect. So let's say def init and self query, but here we do not want to put query. We, let's say, want to put anything, let's say user. Make sense? So what it will do, it can simply say self.user equals to user. Make sense? Perfect. So now I can simply create a function, let's say show me. Okay, and within the show me, what I will do, I will simply say I want to print the username with the, let's say anything, let's say this one from Claude or anything. Make sense? Or we can do also one more thing, which will be like really dynamic and it will be fun. Let's say you want to call this function based on the, you can say, model that the user is passing. Let's say model here. Let's say model. Okay, self.model equals to model. So in the show me, in the print command, it will simply say I am calling, okay, which model? Self.model. Okay, this is sorted. This makes sense. But now, do you know what will happen? Now, obviously, you would want to just call the model, right? You would like to call the model. Okay, so how you can just call the model now? How you can just access the functions which are built in this particular class? It's very simple, and it's the, you can say, fundamental rule of inheritance. You can simply call any object, any function, any method of your parent class using two functions. One is super, second one is the name of that particular class. So I prefer using names. Let's say LLMs dot now I want to just call the function. Let's say I want to call Claude function. Let's say LLMs dot Claude. Make sense? LLMs dot Claude. I want to just call this function, and the function is this one, Claude. Okay, simple. So it will simply print this. Why? Because I'm calling this function called Claude. Simple. So this will call this function. Make sense? Very good. Sorted. But do you know what? This will not work. Why? So this is very important. Whenever you inherit any class, you need to pass all the variables which are defined in the parent class. That means this variable should also be initialized in this particular class. Now there are two methods. You can simply define like this: self.query equals to query, and obviously you need to ask for the query from the user. This is one way of it. if you do not want to run like this, like write like this, you can also write something like this. Let's say llms dot underscore underscore init underscore underscore, and then you can simply pass query. So what will happen right now? It will simply call the init function of this particular class, and it will simply create the class variable for our inherited class. What is the advantage of it? Let's say in your parent class you have 100 plus variables. Obviously you do not want to write 100 times self dot this, self dot this, self dot this. You can simply call this function and pass all the parameters and done. Boom. Make sense? Simple, sorted. Simple and sorted. Makes sense. Okay, very good. So let's call OpenAI here because we are using query as well. Okay, perfect. So now let's see how we can just create an instance for it. Let me first save it. Let's say object inherit. Okay, object inherit equals chatbot, and now I want to pass two parameters. One is model. So model is OpenAI, and the query is, hey, I am anshlambacollab. Okay, so this is the object. Okay, let's simply run this after saving it, and it will say, hey, query is missing. Like, what is this query? So here you need to simply say, what is the error, by the way? Object inherit chatbot. Okay, LLMs inherit missing one required positional argument. So do you know the error? First of all, it is saying one required positional argument query is missing. So if you remember the fundamentals, we have to pass here not self, basically just add here self, because we are defining these particular variables. Make sense? So let me just run it and save it first of all. Okay, perfect. So now this is like created. Let's print the command and obj inherit dot OpenAI. Okay, and we want to print it as well. Let's say print. Perfect. So let's run this. Make sense? So now it is saying I am OpenAI. You asked, hey, I'm Anshlamba. Perfect. Make sense? So now let me show you how you can just run it through terminal as well. Let me just open the terminal. So here, if you're using PowerShell, you need to use some, you can say, double quotes, because it cannot expect spaces. Okay. And by the way, I can just rename it. It's a better way to rename it. Makes sense. But I will just show you, don't worry. So in order to just run this, you can simply say Python. I personally use UV to run these particular files, but Python also works because UV is like a modern package manager. So Python, and then location is chapter 1 classes, and within that we have inherit class.py and hit enter. Oops. Perfect. What is this? Chapter 1 classes. Okay. Inherit class.py. Okay, everything is fine. Let me just rerun the command because I think file was not saved. So let's rerun this. Perfect. So now we have this particular, you can say, command to run the files. Okay, so this was the way that we can just import, or basically the, you can say, right way to import the classes and inherit it accordingly. And you will be seeing these kinds of things in, you can say, in the modern world, where we are just making so many API calls, so many classes, so many, you can say, API references of the modern AI data engineering frameworks. And also, you know, like how actually we are using these things now. Make sense? Because for software engineers, it is very obvious, because they are actively working with classes, actively working with inheritance and all. But data engineers do not like actively working with these things. Whenever they just create a class, they hardly use it, let's say, in the form of inheritance, in the form of referencing in the multiple notebooks. And also for data engineers, this was the gap that is filled now, I hope. Make sense? So very, very, very good. So let's save it and let's jump on to our next chapter. And it's an amazing chapter. Next one. So it says chapter 2. What is the chapter name? The chapter name is, are you excited? Multithreading. Data engineers, this chapter is like, you can just understand this chapter better than anyone else. Really, trust me. Trust me. Because in the programming world, it's not like just software engineers can understand some stuff. There are so many areas that data engineers can understand things better. And now this is like one of those things. Let me close this file and let's create our first file within this. Let's say basics.py. So what is first of all multi-threading? So you, my lovely data engineer, let's say you have developed a function using def, let's say transformation. Okay, you are transforming some data using PySpark code or using anything. Okay, makes sense. So let me write pass. Okay, so let's say this is your function. Okay, makes sense. This is your function. Now you want to perform the same transformation on top of, let's say, 100 tables. Whoa, let's say 100 tables. You want to apply the same transformation, all these steps, everything on 100 tables. How you can just do that? Let me add one. Let's say 100. I was just about to add one more zero, but let's say 100. You will say, Anshlamba, it's very easy. You know that like we are ultra pro max Python developers. We know that how to do this. We can simply write this for loop for, let's say, I in range, then 0 till 100. And we can simply call this function, let's say, transformation with some parameters if required. And this will perform the same transformation 100 times, obviously on the 100 tables automatically. So see, we are like ultra pro developers and we know how to do this. I know you are an ultra pro developer. So let me just ask you a quick question. 100 tables. Each table takes at least 10 minutes to process one data. Let's say it takes like 10 minutes to process data for one table. 10 minutes. How many minutes? How much time it will take? 100 into, let's say, 10. If it takes 10 minutes. Okay. 1000 minutes. 1000 minutes. Do you know 1000 minutes? Okay, so what are you expecting? I do not want to spend 1000 minutes to process, to transform my data. 1000 minutes means, Anshlamba, you did your bachelor's in mathematics. Yeah. So I did my bachelor's in mathematics, but I was not told like how to be very quick in just dividing some stuff or become, I didn't like pursue bachelor's to become a calculator. I had the calculator in my bachelor's. Okay. So 1000 divided by 60, whatever you can say, 1000 divided by 60. What is the answer? Oh man, wait. Let's cancel this 0 and 250, 3. Okay, and 315. Almost. So 15 hours. 15 hours, are you sure? Okay, let me just use this. 1000 divided by 60. Close. 16 hours. 16 hours. What? So you are saying that you will take 16 hours to process your data? Are you serious? 16 hours. Wow, man. Because obviously there are 100 tables and each table takes 10 minutes. So 6 tables will take at least 1 hour. So 16 hours, and you are saying like you are a pro developer. 16 hours. What if I say you can process all the 100 tables in, let's say, 15 minutes? It's not possible. Why? Because you have 100 tables and you will process all the tables in a loop and it will take 10 minutes. So it will take at least 16 hours. You cannot process the data in 15 minutes. It's not possible. It is possible. Okay, and what's the recipe behind it? It's called multi-threading. So what happens in multi-threading? First of all, multi-threading is like a lighter version of multi-processing. We do not perform multi-processing because we are data engineers, okay? And we work with Spark clusters. So we do not need to actually perform any kind of multi-processing, but we can perform multi-threading. And one key point that you need to note right away, okay? And this for like, I'm just referencing data engineers because I love my data engineers, but it is for like all. I know like even if you're not a data engineer, see, in the AI world, I would say if you are a data engineer, you have an extra edge over software engineers as well. and you will know the reason along with this video, and I will just let you know. Okay, so let's say you are processing the data, okay, and you are already using Apache Spark and all. You do not need to worry about those things. Okay, so multi-threading is just used for orchestration. Do not use multi-threading for transforming the data, building the transformation logic. No, you do not need to do that, because Apache Spark is already handling those things. We are simply using multi-threading for orchestration. Let's say you build a function. Okay, this is your DEF. Now you are using multi-threading to orchestrate it. Okay, this is multi-threading. This is multi-threading. You cannot insert multi-threading inside your function. No. Okay. No. Okay. Makes sense? Very good. So now you understood multi-threading is for the parallel processing. Makes sense? Parallel processing. You do not need to run all the things in series. If you have studied a little bit of physics, you would have built circuits, series, parallel, all those things, R1, R2, 10 ohm current and all. Do you remember? Okay, if not, it's fine. So series and parallel is like very common thing. If you just want to run, let's say this is your one instance, then second, then third. So these are in series and these are dependent on one another. But in parallel, you simply create one, okay, and this is second, this is third, this is fourth. These are not dependent. These are like parallel. These can run independently. So multi-threading helps us in this particular scenario. Okay, so let's quickly create our first function. Let's say transformation. Transformation, let's say we don't need any kind of, let's take one, you can say input can be anything. Let's take I want to just show you the real example. So let's take an example of an array, because in the real world you will be just using an array of dictionary. So let's say you want to just use a dictionary. Okay, if you just want to use dictionary, you can simply say, and I think there are some data types from typing, import dict. Perfect. I think there was like small as well. Okay, and it's fine. It's just for type hinting. You do not need to have libraries. Okay, so now let's say, let's even remove it. It's fine. So let's say you want to create a function transformation, and you will simply say input. Okay, simply input. Input can be of any type. Okay, because we are not specifying any kind of type hinting. So let's say within this transformation, you want to use something called as your source. Source is input of source. Okay, I will just define it, don't worry. Destination is input destination, because we are assuming that this particular input is a dictionary. Make sense? Very good. So source and destinations are here. Oh man, my code completion. Okay, so source and destinations are like here. Okay, now I'll be using it. So let's say I want to print one thing. I will say reading from source. Okay, and here you will write your reading logic. df equals to pd.read.csv. Make sense? The code that you write for your data frames for your PySpark. Make sense? Not pd, okay, because this is not pandas. Like simply write df equals spark dot read csv dot format. Okay, or like read dot format then csv, whatever you want to say. So this way you can just initialize your data frame and you can read it. I'm not writing that code, simple print statement. Then I will simply say you are writing the code after transformation. Okay, or even like you can say transforming the data. Transforming, transforming. Okay, transforming, and you can say print f writing the data, writing data to destination. Make sense? Very good. So this is our function that we want to run over multiple tables. We want to read the data, we want to transform it, we want to write the data. Simple. Now we want to orchestrate it in the parallel framework. So I'll simply create, or basically first of all import some libraries. It's called from futures.concurrent. I'm not sure if I've just downloaded that particular library here or if it's a built-in library. We can check. From futures.concurrent, we need to import futures or future. Let me just check it quickly. From futures.concurrent, we need to import thread pool executor, and you can also import threading or import threads or threading basically. So there are like two ways to create threading or basically multi-threading. One is individual threads, or the modern way is creating the thread pool executor. What is that? Thread pool executor. So let me just quickly check what is the library that we need to import for that particular thing, because I remember like there was a specific library for thread pool executor. You will say, hey Anshulamba, do we need to learn both the ways, like threading and thread pool executor as well? Like, to my knowledge, I would say you do not need to worry about individual threading, because the reason is you will be using with the modern way, and I want to just show you the modern way. So I do not want to just spend your time in threading. It's like very simple, very similar, but just learn the modern architecture, modern frameworks, right? So I can simply say from concurrent.futures import thread pool executor. Simple. So let's actually import it, and maybe if it's not a built-in library, we can simply add it from concurrent.futures import thread pool executor. Yeah, it's a built-in library. Fine. So this is a thread pool executor, and how we just create this thread pool executor, it's very simple. And even before calling this thread pool executor, you should have your array ready. Array means that particular 100 tables, right? Let's say in this particular scenario, we are not writing 100 tables. Let's take an example of 3 tables, but obviously you can just pull 100 tables. Don't worry. The main intent is just to show you that you can just read and write from different tables in parallel. And don't worry, I'll just show you 100 tables as well. Let's get started with 3 because I want to show you the output in the terminal as well. Okay, so let's say array is this, and let's create array of dictionaries. Okay, so in this dictionary, I will create objects like source. Source will be, let's say, table 1. Okay, table 1, and then we have destination. And destination is table 1, obviously. Make sense? Who hit the enter button? Who? Let me just copy this and let me say table 2, and let's create one more, table 3. You can create 100 instances if you want. It's up to you. Okay, so this is my array. Now I want to run my function to these tables but in parallel. Okay, so for that I will simply write a code. It's called with thread pool executor. Like, what is thread pool executor? Thread pool executor is like managing your threads. Now each thread, you can, for understanding, you can treat it as like a single branch that is running your, or you can say iterable, but that iterable is not running in series. That iterable is running in parallel. That's the only difference. That's the only difference. Make sense? Okay, so I will simply say with thread pool executor. Now we need to say max executors, or basically workers. Now what is max executors, or basically max workers? So whenever we just create thread pool executor, we want to set the parallelism. Here we have 3, you can say, instances. I want to run all these iterables in parallel. So I will simply say max workers equals 3. Make sense? And I will create an instance of it using executor. Make sense? So this is one thing. Okay. Now I want to say, hey, this is my thread pool executor. That means I have the capability to run 3 things in parallel. You can say I have created the engine, okay, that can run 3 iterables in parallel. Now I will create, you can say, an instance where I will say, hey, take this array, take this function, run this function, and use this array to run this function. So I will simply say executor dot map. Okay, and then the function is transformation, and array is this one. So basically transformation is your, like, you can say, function name that you just want to define. And you can also say like function equal to this and blah, 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 but it's fine. It will automatically fill the function with function and array with array. Make sense? So now we can also save this whole execution with something called as a variable called futures. And it is not like hard and set rule. You have to just pick this name. You can say my futures. That's it, sorted. So what is this variable like my futures? This will basically hold the output of your function. Here we are using print statement, it's fine. But let's say your function is returning something because you are just using a return keyword to return something. So this my futures will hold that particular, you can say, value in a list. Okay, and I will just see that as well, don't worry. So this is fine. Okay, let me just run this. So if we just want to run this, it is very simple. We can simply say like run it, and what will happen? Boom. Whoa, boom. See? So what it has done? What it has done? It has said reading from table 1 and reading from table 2 together, and then transforming, reading from table 3, writing from table 1. So what is happening here? It is performing all the things in parallel. So that means it has run this function. It has run this function for table 1. Okay. Then immediately for table 2, immediately for table 3. Oh, immediately. So that means now all the tables are running in parallel. That is the power of this thing. And now you know the power of it. Now just imagine that you are working in an organization and they had one pipeline, okay, and that pipeline was taking 16 hours. Maybe they were not updated with this knowledge or anything. They were just using that pipeline, and that pipeline was taking 16 hours to get completed. You entered the organization and you said, hey bro, what are you doing? And you proposed this solution and you built this solution and you said, hey, see, now your 16 hours are actually reduced to 10 minutes or 15 minutes. See the difference? And they'll be like, wow, 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 we gonna promote you. So this is the way that you need to just use these things in your data engineering world. Make sense? So let's say your function is also returning something. Let's say return completed, done. Let's say done. Okay, done, and you can say source, so that we will be source to destination, done, source to destination. Make sense? Okay. And F as well. Yes, we need to write F. Perfect. So we'll simply say, hey, it's done. So what will happen if I run this? Obviously we'll see the same result, but this time I will not see that particular done. So if I print here my futures, let's say I will say print F, the returned values are, okay, then you can say my futures. Okay, if I run this, you will see returned values are this. So it will not immediately give you a kind of, you can say, the values. No, you have to convert it into a list. Make sense? Because my futures are actually holding the instances, basically the objects. So you can simply say list of my futures. And now let's run this. See, this way it holds every value of your function that you can store. Even you can use it to create logs for your data processing. Make sense? I hope it was helpful. So this was all about multi-threading and parallel processing basically. Okay, make sense? Very good. I hope it was understood. I hope it was relevant. I hope it was insightful. Yes, if yes, do let me know in the comment section. See, come here bro, come here sister. Why you feel hesitated whenever you just want to comment? See, your one comment means a lot to me. You will be thinking like, hey, what will happen if I will writing a comment? Your one comment means a lot. Trust me. Even if you are not feeling that, it's not like you will be feeling important or blah blah blah. It really matters a lot to me, for sure. Okay, so just drop some comments, and by the way, just use this particular opportunity to talk to each other. This is your community as well. This is our community. So just use this community to talk to each other, to just, let's say, solve each other's doubts. This is the way you grow. I think you haven't lived in the era where people were just solving and like actively contributing in the community, such as Stack Overflow and all those things in the software engineering industry. Data engineering is not different. You have to do all those things in the data engineering community as well. Try to solve errors of each other. That's how you grow. That's how you know what can be the errors. And those errors can be your interview questions, can be your errors as well in the future. So just try to read the comments, just try to solve, just try to help others. This is your community. Just use this opportunity. This is all for you. I'm doing everything for you. I know that you are really, you can say, working hard for your goals, for your, you can say, learning, career and all. This is one part of it, and you need to add this into your career goals. Trust me, it will help you a lot. Okay, enough guidance, philosophy. Okay, so now let's create our chapter 3. So this chapter 3 is amazing, and I would say the most demanded topic. What is that? It's called async. Wow. If you have heard about this concept, you would be like, you would be having a cute smile on your face. Asynchronous Python, and yes, we're gonna just master this concept today. Okay, let me just create chapter. Let's say basics.py. Make sense? So what is asynchronous Python? And you will also know the reason why I discussed multi-threading. Okay, because now we're gonna level up. Okay, so hold your breath. It's like the moment. So asynchronous Python is the behavior that is recently added in the Python framework, which was not there before. And asynchronous behavior is there for all the other popular programming languages such as C, C++ and all those, Java and all. But in Python it was missing, but now they have added asynchronous capabilities in Python as well. And in the AI world, everyone is using asynchronous behavior. Okay, so whenever you see async word, that means they are using asynchronous behavior. Okay, and today you're gonna master asynchronous behavior. And let me just open my notebook, because in this particular chapter I have to just cover all the things in a sequence and I don't want to miss anything. So that's why I created the, you can say, a kind of index that I need to cover. And let me just open it very quickly. Perfect. So first of all, we need to cover what is asynchronous behavior and what is an event loop and how asynchronous is different from multi-threading. So that is like few topics that we need to cover first of all. Okay, then we will just go to the code. Okay, show some excitement, bro. Okay, so let's talk about asynchronous Python. Basically, asynchronous means which is not synchronous. So bro, see, it is what it is. Trust me. So if you do not know how Python interprets the code, Python interprets the code. First of all, Python does not compile your code. Python interprets your code. That means it interprets your code line by line. Tuck. That means, that is why we do not have any kind of semicolons that we have in C++, right? I still remember like when I just wrote my first C++, you can say, code when I was in 11th standard. So see, I was not from the, you can say, coding background, and I didn't even have a computer at that time. And I'm not kidding. Okay. So in 11th, I just looked at the code. I was like, what is this? So, and I just, you can say, changed my school after 10th standard, because my previous school was just like till 10th standard. And in the 11th standard, I changed my school, and it was like really a high graded school, and everyone was like pro people like in coding and all. And they already had built the applications using VB, Visual Basic, in the class 8th and 9th. And I was just sitting in the class and everyone was like pro developer, pro coder. And I was just sitting like literally dumb. And professor came and she started like teaching something called a C++. I was like, what is this C++? I have only taken game on the computer. That's it. GTA Vice City, that's it. And she was just using something like this. I still remember those snippets. So it was like something like this. Let's say, I never used C++ after that. I'm just telling you. So it was like hash include, I think iostream.h. and then I think it was like void main, something like that. Yeah, then there was like C out, hello world, and if you just want to use C in, if you just want to take the input, it was like this, if I'm not wrong. So this was the code that was like being written in front of me. I was like, what? I still remember those days, like those were like fun. Okay, and I was the joker of my class, let me be very honest, because I was like zero, literally. And whatever questions I used to ask, like the whole class used to laugh. I was like, okay. those days. Oh man. And she was my class teacher as well. So what used to happen? Okay, let's talk about this on any other day. I don't want to just share everything. Okay, so now let's talk about the asynchronous behavior. First of all, we need to talk about what is asynchronous Python. Okay. So in asynchronous Python, we say run our resources, basically run our code, not in parallel, but in asynchronous behavior. Listen to me. That means in multithreading, or forget about multithreading, let's talk about parallelism. If I want to run anything in parallel, okay, and I have, let's say, 5 functions. Make sense? If I want to run this code in parallel, I will simply say run all the 5 functions in parallel. Let's say F1, F2, F3, F4, F5. Make sense? F1, F2, F3, F4, Anshlambacollab, you better not write anything. Okay, F1, F2, F3, F4, F5. So this is parallelism. But asynchronous is something different. Asynchronous says if you have, let me remove it. Let's say asynchronous. Asynchronous says if you have 5 functions, okay, do not run all the 5 functions together. Okay, it will say run first function, F1 and F1, and keep it running. Okay, the moment, listen to me, the moment it got idle state, run my second function. Oh, okay, yes, run my second function. If this function is in the idle state again, then obviously you can just run this function, F3, and if it is in the idle state, then just do this. So basically, just to summarize what happens, this will not run F1, F2, F3, F4, F5 in parallel. It will run this one, F1. It will keep on running. If it is in the idle state means it is waiting for some response. Let's say you have made an API call. If you have made an API call and your Python resources are not being used because you are just waiting for the response from the API provider, or basically who is the API owner. Your Python resources are not being used at that time. Maybe let's say for 2 to 3 seconds. That is the idle state. So whenever you see any kind of idle state, it will simply say, why I need to wait? I will just perform any other task. So it is saying I will make the maximum use of my Python resources. I will not sit in the idle state and wait for the resources to come. No. It will simply say, do this task. If you are waiting for something, just start the second task. If you are waiting for that thing, start the first or third task and just juggle between these tasks. You do not need to sit in the idle state. I think that's what your managers ask you to, right? Okay, so now you need to juggle between tasks. You need to juggle. But in parallelism, you are running everything together. That is the difference. Oh, okay. This is interesting. Yes, this is interesting. And it happens with the concept called event loop. Now, what is event loop? Event loop is basically the concept that says this same thing, but you can say a kind of loop. It will start one thing, start one process. If that process is waiting for something, it will go to the next one, and then it can simply put the results and all. And let me just see if we get any good diagram on browser. Async Python event loop. Let's see. Oh, they have in the official documentation. Nice. I doubt if they will be putting any diagram, because they hardly put any diagrams in the documentation. No, they just have code. Okay. No, they don't have anything. But I think this particular documentation is also very good for, you can say, your asynchronous behavior, which is called event loop. And in this particular table of content, you can see event loop methods, running, scheduling, TLS, upgrade, blah blah blah. You can just simply read it. It will be helpful, obviously. And it is all about like your asynchronous behavior of the Python. If I just say asynchronous Python, let's see what we get. Not event loop, without event loop. I just need to make sure that we get the same documentation page. Okay, this is asynchronous IO. Okay, run Python go routines. Okay. So, okay, if it is not available, it's fine. It's fine. We can just check some images, maybe. Okay, we can just see this. Oh, it is a Microsoft Bench. Okay, it is a good search engine. Okay. So see, this is an event loop where we have queue of task. Task 1, task 2, task 3 equivalent to function 1, function 2, function 3, which is obviously a task, right? It takes the task, which is called get task. Then it starts the event loop. How it starts the event loop, it is very important. I will just show you through the code. Then what it says, it just create a thread. Thread is basically, you can say, similar to multithreading, but not in parallel. I told you, not in parallel. It will create the thread. Okay. Then it will simply just keep on running, respond it if it is running. Okay. Then it will take the second task. But if this particular thread is in the idle state, it will simply pick the second task. Simple. Because it cannot be in the idle state. Not at all. Not at all. Make sense? Make sense? Make sense? I know it is like blurry because it is like dependent on the upcoming topics as well. Yes. This is a kind of tricky, but it will be very, very sorted once you completely watch this particular section. Okay. And let me just show you the code. Okay. You will understand better. So let's start with importing the library. You need to say import async IO. Async IO. Perfect. So this is the library. So this is the library called Async IO. Make sense? Now we need to talk about something called as coroutine. What is a coroutine? In asynchronous Python, we do not create a function. We create coroutines. Okay, what are coroutines? Coroutines are like, you can say, special kind of functions which starts with async keyword. Let's say async and then my function def, let's say process. Okay, process. And this can take any variable if we need to, otherwise it's fine. Okay. So now this is a kind of coroutine. This is what? Coroutine. Okay. Just listen to me. Okay. Just listen to me. Make sense? So, okay. Make sense. So what we need to do now? Let's say I want to print something. I will simply say print first step. Make sense? Then I will say print second step. Make sense? Okay. Now, what will happen? You will say nothing. If I just call this function, it will simply say first step and then let's say second step. Okay. And yeah, that's it. That's it. Make sense? What if I add something called as async IO dot sleep? Okay. You cannot use here time module because time module is not asynchronous friendly. Why? Let's say I'm using here time.sleep. So there are some libraries which are not asynchronous friendly. Why? Because you will use here time.sleep Okay, I need to import time. Okay, sleep means sleep. That means Python resources are not being used. But you know what? The asynchronous libraries, basically non-asynchronous libraries which do not support asynchronous behavior, even if the Python resources are not being used, they lock the resources. Okay, so let's say time.sleep 3. I know Python resources are not used, but they will lock it for 3 seconds. So ideally, it is not in the idle state. So that is why we have to use async io.sleep. Now async io is an asynchronous library, obviously. So now sleep means sleep. Sleep means you are in the idle state. Make sense? Very good. So now what will happen? Now let me just show you. If I want to run this particular coroutine, how I can just run this. I have to use async io dot run, and now I need to just pass the coroutine name. Perfect. The moment I run this, it will initiate my event loop. Make sense? It will initiate my event loop. Okay, make sense? So whenever we run a coroutine, an event loop is initiated. Remember this point, this is very important. Okay, now if I run this, what will happen? You will say first step, then it will wait for 3 seconds, and then second step. Really, let me show you. So first of all, we have a value error. What is the value error? Async io.process, async io.this, async io.this. What is the error name, man? But let me just check async io. Oh, silly mistake. So it is saying, hey, see, here it is written. It is saying, hey, what is process? What is process? Process is a function. Silly mistake. So now it is saying first step, second step. That's it. Immediately. Anshlambacollab, you defined here 3 seconds, right? Okay. 3 seconds just passed very quickly because time passes so quickly nowadays, right? So that is why. Shut up. Even if I say 30 here, and let me just run this. Immediately first step, second step. Why? 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 Oh, maybe Python is skipping this command. No, bro, it is not skipping. That is asynchronous behavior. So what is happening? First of all, it ran this command, it executed this command, first step, sorted. Immediately, it went to the second line because Python runs the code step by step in the lines, right? It got this command, async io.sleep. That means Python resources are in the idle state. That means they can perform the next task. It simply performed this step. Second step, that's it. That is asynchronous behavior. Because I want to make sure that my resources are being used correctly. Because this is an idle state. Sleep is an idle state. Here, obviously we are using sleep, but in the real world, there can be an API call. There can be an API call. So I'm saying that whenever you just make an API call, the real API call, not those like simple demo API calls where you just get the data like this. No, in the real world, when you just need to fetch the data, it takes some time because in those API calls, maybe you are just bringing millions of records. So it takes time, right? So in those scenarios, you can just leverage this. And we have just created this environment where we are just assuming that this is an API call or any kind of call, any kind of code where we need to wait for some time, where our Python resources will be in the idle state. Make sense? Make sense? Okay, good. So now what is happening? It is simply saying, hey, why you need to wait? Simply step the other things, bro. But sometimes, let's say this particular step is dependent on this task. That can be the case. Very simple. Because usually, if let's say I am making an API call like this, let's say result equals, I'm just making an API call. Okay. Blah, blah, blah. Okay. So this is my API call. Let's say I want to print this. Let's say I want to print this. So if I do this, will it work? Obviously no, because this will be in the idle state. It will directly jump on this particular thing and it will say, where is result? I do not have any result. So in that particular scenario, we have something called as, first of all, let me just undo the code. Second step. Okay. For that particular scenario, and let me reduce the time. Let's say 3 seconds or let's say 6 seconds. Okay. So in that particular scenario, we have to use something called as await. Await is a kind of block. It will say, bro, hold on. I know that our resources are in the idle state, but you need to complete this step before going to the next step, because our next step is dependent on this particular thing. Oh, so await is a kind of a flag that tells, hey, just pause this coroutine here and come back when this thing is done. Make sense? You can pause your coroutine, because whenever you just run this coroutine, it starts the event loop. Okay, if that particular coroutine is in the idle state, it will pause it and it will wait. The moment it is completed, it will simply resume the event loop. That is the power of await keyword. Make sense? Now if I run this, do you know what will happen? It will still wait. Okay, and we know that our Python resource will be in the idle state. Still it will wait. Let me just show you. So it will say first step, and now it will wait for 6 seconds. Now see. Perfect. This is the power of asynchronous behavior. This is the very basics, very fundamentals. Okay, very fundamental. So we need to just level up slowly. Okay, then only you can understand it, because it is very tricky. But when you will be taught with the structured approach, it will be very easy. It's all about like, who is your mentor, right? Okay, so first step, then sleep, then second step, because we are using await command. Very simple. Okay, makes sense. So now, and remember, whenever we just run this thing, that means event loop begins. Make sense? Very good. Okay, now let me just show you what will happen. What will happen if we have, let's say, 2 coroutines, basically 2 different special functions. Because this is obvious, like this coroutine behavior, this particular coroutine behavior is very obvious within the function. Will it work outside the function as well? No. If I run like this, let's say I have the same function, and let me say process 1. Okay, and if I say process 2, okay, and I can say first step, I can say process 1, just to make you understand. Process 1, and process 2. Okay, boom, perfect. So now here we can say process 1. Okay, now I will say event loop 1 begins. Oh, okay, and I will say event loop 2 begins. Now what will happen? Will it follow the asynchronous behavior outside the coroutine? The answer is no. Because outside the coroutine, it is normal Python, and Python always executes your code line by line. That makes sense. So what it will do, it will start this particular function and it will wait for it to complete. And yes, if we have the logic inside the coroutines to perform your processing in the idle state, that is a different story, but it will not. See, let me just explain you step by step. I will run this. What will happen? It will run this function. Okay, let's be serious for just few minutes. So this is like function. Okay, it will just run this function. What will happen? First step, very good. Let's say first step, good. Then it will go to the idle state. Make sense? Let's say I am removing this await. Okay, await. Or let's say I have just removed this await. What will happen? It will directly go to this particular step. Make sense? And it will not run this thing. No, it will never run this thing. It will first complete this particular coroutine, then it will go to the second coroutine, because this is Python. Okay, this is Python. This is not any kind of coroutine. Coroutine is just this one. Make sense? Okay, so what is happening here? Even let's say I'm writing await. Let's say keep await here. So await will pause Await will what? Pause the event loop, as you just mentioned. So that means this particular Python resource is in the idle state. Okay. And this coroutine is in the idle state. Will it process this particular coroutine? The answer is no. Why? Because it will only run this thing if this is completed, because this is Python. Makes sense? So let me just see the output. So let me just tell you what will be the output. First of all, step 1, 6 seconds, step 2, then first step, 6 seconds, step 2. Let's see the output. So first step, very good. 6 seconds, it is not starting process 2. Why? Because coroutine is just, see, now second step is over, then only it started process 2. It didn't like started immediately because that is a different event loop. This is a different event loop, and coroutine asynchronous behavior only and only happens within the event loop, not outside the event loop. Obviously, in the next particular, you can say module, we will see like how we can just run this thing in parallel, because sometimes we need to, but for now, this is the thing that you need to do. Make sense? Very good. Now we're gonna level up, okay? Because it is required, because you clicked on this video. It's my responsibility to make you a pro. So we need to level up. Okay. So now let's talk about a complex one, but it will be fine. Don't worry. Now, first of all, let's see how we can just call a coroutine within other coroutine. Coroutine within other, you can say another coroutine. How? So basically, let's say this is process 1. Okay, let me just remove this. Okay, this is process 1, and let me just snooze it. Okay, perfect. So this is yeah, perfect. So this is process 1, this one. Okay, and here I'm saying, let me remove await. Okay, that means it will be in the idle state and it will process this thing. Yes, you are right. So let me show you a very good example. Okay, so let's say I want to remove await from here as well. Okay, and let me just reduce the time to, let's say, or maybe we can increase actually. Okay, let's say 9. Okay, so what I'm gonna do, I am gonna call this particular coroutine inside this coroutine. And how we can just do this? It's similar to normal function calling within another function, but using await function like this, await and process 2. Perfect. Simple. Await for blocking that particular thing and then function name. Make sense? Okay, very good. Now what will happen? It will start the process 1. Yes. Then it will go in the idle state and there is no await here. That means it will not block it. So it will directly go to the second step. Okay, second step here. And what it will do, it will call this function. Oh, okay. It will call this function. Okay. Then what it will do, it will start the first step and then again it will go to the idle state. Make sense? The moment it will go to the idle state, it will again start the paused step and then it will go to this particular thing. This is the event loop. This is a very good example to see it. Let's actually process it and let's see it with our eyes. Okay, so now, okay, let me just call the coroutine. Like, let's start the event loop. Let's say async io dot run and then process 1. Perfect. Oh, process 1. Perfect. Let me just run this. Let's see the movie. Oh, there can be an API. What is that? Wait. Okay. Oh, makes sense. Makes sense. Okay. Actually, this was executed. Okay. Process 1 is fine. Okay. First step. Okay. Then it is saying coroutine sleep was never awaited. But we do not want to await it. That's fine. There can be enable runtime warning. Enable. Oh, that is just a warning. Makes sense. Oh, actually that was fine. That was fine. Very good. So do you know what actually happened? There's not an error. This actually went like boom. Okay. So let me just show you what happened. It started the process because these are just warnings. These are not errors. So process 1, first step. Very good. And then our process 1 has an idle state. okay, of 6 seconds, it immediately started the function which is process2 because we called that function. Make sense? Simple. Then it again went to the idle state. Make sense? Went to the idle state, and then it just started the step 2. And let me just add one more print statement here. Print, it will be like more clear after that. Process 1 second step. Okay, now it will be like more clear. Perfect. Let me just show you what actually happened. So it is saying first step sorted. Okay. First step, then idle state, it went to process to first step. Very good. Then it got the idle state. Okay. So what it will do, it will immediately run the next step, which is process to second step. Once it is also over, it will go back to the previous paused, you can say, coroutine, which is process 1 second step at the end. Oh, okay, makes sense. But if I add here a wait like this, what will happen? It will not go to process 2 immediately. It will first wait for 6 seconds. Then it will go to this particular function, basically coroutine, and it will wait for it to get completed, and then it will go back to the process 1. Make sense? Make sense? Make sense? Very good. And here we are not using await, but ideally we should use await. Okay. So now we can just run it just to see the flow. First step. Okay. And it will wait for 6 seconds. Then it will say first step process 2. Very good. Now it will wait for 9 seconds. And then it will say second step of process 2. Very good. And immediately process 1 second step. Very good. This is the thing that you can use when you just want to make a coroutine, you can say, call within an existing coroutine. Make sense? Make sense? Make sense? Make sense? So now your coroutine can also like return some data if you just want to. Let's say, because it is just a function, right? So let's say your coroutine process 2 returns something. You can say first step. Okay, it is returning this thing. Let's say return process 2 completed. Process 2 completed. Okay, makes sense? Not F, because it's a text. So how you can just use that particular value? So this is a coroutine, okay, and this is the value. So in normal functions, what we do, we simply write the function name and assign it to a variable. Same thing here. You can simply say result. Result equals await. Okay, and then you can even print that as well. Print process to result. Make sense? Let me just run this and let me show you. First step, then 6 seconds, then process to step 1, like first step. Perfect. Then 9 seconds, then second step. Okay, perfect. And process to result. Process to result. Okay, makes sense. We didn't use the variable instead of text. So you can simply say process to result. And then this is the result. Okay, let me just run it. Let's wait. Make sense? So now we wanna talk about multiple, you can say, coroutines, and ideally I think, let me just check, what do we have next? Multiple coroutines are also done. Okay, let's talk about this thing. This is, I think, the last thing of this particular chapter, but it is a critical one. So just listen to me carefully. And oh, why it is returning result like this? Because of f string. Let me just run it one more time. I hope it is giving you an end-to-end thorough understanding of asynchronous behavior. Okay, because asynchronous behavior is new to everyone, including me as well. Okay, and people are not actually using asynchronous functions, including me as well. Okay, but I would say more you use asynchronous functions, asynchronous behavior, more you will see errors. Yes, that's the reality. But more proficient you will become, because you do not know like which libraries are using asynchronous behavior. For example, APIs are not like very handy, like request modules are not like asynchronous friendly. So you will know those things whenever you will be just using those things. Okay. And don't worry, I'm here with you. Okay. Don't feel like you are dumb. You're not dumb. Okay. You are very smart. And you are hungry for your goals. That's why you are on this video. Okay, so now I'm going to talk about asynchronous tasks. Asynchronous tasks. Remember our example where we just processed two functions? Let me just recreate that particular scenario. Let me copy the code. Let's create our second file, which is called advanced. Advanced.py. Perfect. Up. Oops. Perfect. So now let's say this is our function one. Okay, let's remove this as well, remove this as well, remove this as well. Perfect. So now if I say event loop 1, event loop 2, so I will simply say async io dot run. Okay, and process 1 makes sense, and I will say async io. Okay, and let's create, okay, wait, dot run process 2. Makes sense. If I just do this thing, what will happen? So let's add await here. Wait, async io dot sleep, 3 seconds. Okay, await async io dot sleep, 3. Okay, if I run this, what will happen? We all know, first step, then 3 seconds, second step, first step, 3 seconds, second step. Simple. Okay, makes sense. So this is like simple. So let me just wrap this code in our main function. Let's create a function called main. Okay, this is our main function. And if I say like this, okay, if I say like this, and let's call this main function normally. Okay, so if you just want to create or basically store this particular function, let's say main, so you also need to just create an asynchronous function, otherwise you cannot call it. Okay, let me just show you. So if you call this function like this, main, okay, oh, it worked. Nice. Like ideally I just prefer using the same behavior like this, let's say asynchronous, because this is just a function. It can work because this is just a Python, right? But ideally you should just use something like this if you are obviously using asynchronous behavior. So make sense? Okay, so now here I can simply say, let me first of all snooze this, spoiler, async io dot run. Okay, and then I can simply say process 1. So now just tell me one thing, a quick question. Should I use here await or not? Like if this is my main, you can say function, should I use our main function here or not? By defining, you can say anything, async io dot run. Should we, let's say process 1, okay, and then async io dot run process 2, like this. Should we let me just show you what will happen. So let me call this main. Okay, df main asynchronous behavior. Perfect. So now when we write this df main, it works. See, it works. See, it works because this is just the main function, like normal your Python compiler Python code, right? But you know what, let me just pause this. Okay, but whenever you define something like this, asynchronous, async df, how you call a coroutine? Within the coroutine, I told you, using await function. So you cannot use async io dot run. You simply need to say await. That's it. await. That's it. Okay. Now in order to run this function, you can simply say async io dot run, which is your main function. Make sense? And let me just run this. Simple. It is running fine. What will happen if I write something like this? Let's say if I write async io dot run process 1. Okay. Then async io process 2. Like, what will happen if I want to run like this? Error. It is saying async io dot run cannot be called from a running event loop. Makes sense, because this is already an event loop. So this will create an event loop, and you are saying create another event loop within that. No, you have to say await. Okay, makes sense. So this is the way to do that. So what it is actually doing? It is performing process 1 first of all, and then it will saying process 2. Makes sense? Process 1, process 2. And we cannot perform process 1 and process 2 in the asynchronous behavior. Really, think about it, what I'm saying. See, process 1. So here, this particular function is called, yeah, and it is saying asynchronous dot sleep 3. Yes. So that means this particular function, let's say I am removing this await function. Let's say this one, await. Okay. Let's keep it as well. No worries. So if you see here, what is happening? It is saying, hey, this is a function. Okay. This is a function, and this is the first step. Then we made some API call or anything. It was in the idle state. Okay. This is the API call. This was in the you can say idle state, and we wrote here await because this step, the next step, print command, is dependent on this thing. So we cannot remove await. But logically, our Python resources are logged. No, not logged, but the event loop is paused for 3 seconds. Ideally, yes. What if I want to do something? Let's say this is my first step. Okay. Now, the moment it is in the idle state, okay, it cannot process this thing because this is dependent on this thing. So that's why I written await. But I know that I have still 3 seconds. Why to waste that? I can, or like I should run this coroutine, this one immediately, because it can perform this step. Okay, makes sense. Then it will go to the sleep state for 3 seconds. Okay, it will go to the 3 seconds. Let's say 6 seconds are there. That means this is again in the idle state, and we know that our 3 seconds are completed by that time, because if it is like 6 seconds here, 3 seconds will be completed by the way. Then it will come back to this function again, basically this coroutine. It will complete that one, and the moment the 6 seconds are completed, this will come here as well. So this is the way, and this is, I know, a little bit advanced topic. You can just rewatch this section, it's fine. Okay, and we also watched like multiple times, bro, when we were learning, so it's fine. Do not feel like dumb. Okay, so how you can just do this thing? We can achieve this thing using something called as tasks. So if you just want to create tasks, so I will simply create task like this. Tasks equals await. Okay, it's called async io. Okay, spoiler is there. Async io dot gather. Then you need to define all the coroutines. See, coroutines or future one. Coroutines. And what is a coroutine? As we know, our first coroutine is process 1. Okay. Our second coroutine is process 2, and that's it. This is, bro, this is our tasks. Make sense? This is our tasks. So why did we write await here? Because we do not want to go, let's say I want to print here processing completed, or let's say main completed. Okay, main completed. So it will only write this command main completed when all the coroutines are completed. All the what? All the coroutines are completed. All the coroutines. Okay. All the coroutines. Make sense? And how these coroutines will be completed? In the event loop. Whenever it will get the idle state. So see, await command is the idle state. We know that, but we cannot go to the second command because this command is dependent on this one. Fine. So we have to wait, but we cannot lose our resources. It will immediately start processing this particular coroutine. And if it gets any kind of idle state, it will jump back to this one. Let me just give here 6. Makes sense. Are you excited to run this particular code? Okay, let me just show you how this works. So it will say process 1, process 2 immediately. Why? Because it got the idle state here. Let's wait for it to get complete. Let me just then explain. Okay. So this is process 1. Okay. First step, it got idle state. That means it cannot go to this step. Why? Because await is used. But we use something called as tasks. Okay. So it started processing our second coroutine and that's it. And it was in the idle state for 6 seconds. And our 3 seconds were completed. So it went back to the coroutine 1 and it completed that coroutine. Then it completed coroutine 2. And then when all the coroutines were completed, it is saying main completed. Oh. This is the entire process, and this is the thing that we need to know in the coroutines and basically in the asynchronous behavior. How was it? How was it? Was it complex? Yes. Is it complex? No. Why? Because you have completed this section now. And I hope this was helpful. Asynchronous, there are like many more things in the asynchronous behavior, but these are the things that we use. Obviously, there are like so many things in everything, but we do not like use all the things. 80% of your tasks related to asynchronous behavior will be completed under this thing. If you understood this thing, it's fine. It's fine. Make sense? I hope it makes sense. So now, what do you need to do? You need to practice this. You need to just rewatch this section if you didn't understand everything, because it's fine. Make sense? Very good. I hope this was helpful. I hope this chapter was helpful, asynchronous behavior. So now what do we have in our next chapter? Let me just show you. Chapter 4. What should we discuss? Because let me just check the flow. So chapter 3 is like asynchronous Python. Okay, we're going to discuss very important thing. It is called Pydantic. Wow. Pydantic is like one of the favorite things in the world of AI data engineering, in the world of AI basically, in the world of like anywhere. Okay. Pydantic. We're going to cover Pydantic in very much in detail. So do not worry about that thing. Okay. And yes, let's talk about it. So now let's talk about Pydantic. And this is gonna be very interesting section of this video. Trust me, because first of all, what is Pydantic? And I will not be surprised if you will say you have never heard this word called Pydantic. Trust me, because see, I just want to talk about some facts. Whenever we say Python, after covering the basics, everyone starts talking about DSA. And every time I say, bro, do not stress about DSA. DSA is for software engineers. You do not need to build linked list, queues, stack queues, all those things. You need to build pipelines first of all. So Pydantic is so important in the world of data engineering, in the world of AI, in the world of like, you can say modern AI data engineering. Why? And first of all, what is Pydantic? Because we are just hearing about this library for the first time. Don't worry. Even if you have not heard about this particular keyword called Pydantic, which is a Python library, you will master this in this particular section. Trust me, because I'm gonna cover each and every corner of this Pydantic, which is like required. Okay. Now, what is Pydantic? And I will just take you to the documentation page. Okay. Let me see if I am able to find Pydantic, because nowadays I can see like search engines are like performing really good. Pydantic. Welcome to Pydantic. Oh, finally I was able to find this. Okay, makes sense. So basically Pydantic is a new library first of all. Okay, and why do we need it? What is Pydantic? Let's talk about this, because this is important. By the way, nice UI, nice color combination. So Pydantic, whenever we just work with Python, we work with so many data types. Yes, but we do not have any kind of capability so that we can validate our data, we can apply some rules on our data types, or we can just parse our data. These three things: data validation, data rules, data parsing. Okay, again, data validation, data rules, data parsing. These three things were missing. Okay, Pydantic actually solves that particular problem. Makes sense. So this is a Python library which adds, or basically which plugins the capabilities so that we can perform data validation, we can perform, let's say, data rules, and we can say data parsing. Why it is important? First of all, let's talk about it. Why it is important? You are a data engineer, or let's say you are into modern frameworks, AI frameworks and all. Every time you need to make sure the data types that you want to receive, you will receive. Again, you need to make sure the data types that you want to receive, you receive the same data type. If it is not matching with that particular thing, you do not need to proceed further, because it can break a lot of pipelines if you are building data structure, data flows, whatever. So you need to make sure your parsing is accurate in the initial stages, plus in all the stages wherever the data is going. Make sense? And obviously, let's talk about a little bit about proper data engineering stuff. Whenever you build a pipeline, whenever you, let's say, migrate some data, you need to make sure like all the column types, all the data types are matching, right? Similarly, whenever you are just building something with the Python code, you need to make sure all the parameters, all the data types are exactly matching. Make sense? Now I hope you will understand like what exactly I'm talking about. Okay. And let's read some documentation. And it is just like showing you the direct code, and don't worry about that. Let's read this. Why use Pydantic? Powered by type hints. With Pydantic, schema validation and serialization are controlled by type annotations. Type hinting, I was just talking about type hinting in the beginning as well. We will be just using type hinting now. Then speed. Pydantic's core validation logic is written in Rust, so obviously it is very fast. And I would say fastest. Pydantic is among the fastest validation libraries for Python. JSON schema. Pydantic models can emit JSON schema, which is amazing. Strict and lax mode. That means, yes, we use Pydantic for data validation. We have the liberty to strictly fail the records, or basically strictly fail the data mismatch, or we can just say, okay, we will allow some things. So we have like these things. I personally call it as strict validation versus loose validation. But let's see what it is written here. Pydantic can run it in a strict mode, basically same thing. Okay, and where the data is not converted, don't worry, everything will make sense in just few minutes. Okay, then we have data classes. Yes, so basically Pydantic supports validation of many standard library types include data class, type dict. So basically this is the dictionary, basically dictionary type, basically whatever we use. Let's say from typing we import dict, list, and all those things. Make sense? If not, it will make sense, don't worry, because you would have never used these things in the past, but now you will use it, because now the world is using it. Now it's your responsibility. Now see, my data fam needs to know everything that is required right now in this modern world. Okay, and yes, it's my responsibility to make you aware of all these things, everything, because you love me a lot, right? So love should be from both the sides, not one side. I know one sided are like better, but yeah, it's fine. Okay, now we have Pydantic examples. Don't worry, I'll just show you the examples. And let's read why use Pydantic. Today, Pydantic is downloaded many times. So should we use it? That's not the question, bro. What is written here? Some of the largest and most type hints powering blah blah blah. Let me just show you. Otherwise, you'll be like, what is this, man? Okay, so let's go to our VS Code, lovely VS Code. Before going to install the library, because you need to install this package called Pydantic, I will be creating a virtual environment because I do not want to install this particular package on my global environment. So how you can also create the virtual environment, it's very simple. I personally love using UV, okay, to handle all these things. But if you do not have UV, you can simply use traditional method. Okay, so in order to create a Python environment, I will simply say Python module venv, and then virtual environment name that I will say .venv, and hit enter, and it has created this virtual environment for me. See, .venv. Now let's activate this. Okay, in order to activate this, you need to say .venv .scripts .active activate. Perfect. Now it is activated. See, I can see this particular virtual environment. Makes sense. Perfect. So this is the way we can activate it. Now whatever I will be installing, like any package, any library, okay, any module, it will not be downloaded or installed in my global environment. It will be just downloaded in my local, this you can say virtual environment. So I will simply say pip install Pydantic, hit enter. You may have installed Python package into your global environment, which can cause conflicts between package versions. Would you like to create a virtual environment with this? Bro, let me tell you, I already have set up the virtual environment. Okay, so this has downloaded this particular Pydantic library in my virtual environment. As you can see, to update, run, blah, blah, blah. So very good. We can also make sure like package is installed. Simply click on this drop down and then go to scripts. Here you should see not scripts, I think include, or maybe library. Yeah, in the libraries you will see something related to Pydantic. That means it is successfully installed in your virtual environment. Okay, let me also try to write Pydantic, maybe Pydantic version, if that is available. No, okay, it's fine. Let's try the last command. If it works, Pydantic -v. No, okay, it's fine. The term Pydantic is not recognized, blah, 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 blah. That's fine. But we know that our Pydantic is there. Okay, that's why I love UV, because in UV we can actually see all the things, but it's fine. So Pydantic is there. Okay, there are some packages for Pydantic. That means it is installed successfully. Makes sense. And we have you can say activated the virtual environment as well. And let me just reactivate one more time. .venv scripts, then activate. Perfect. And now let's actually see, like all the downloading steps are fine. So I think there was like installation. Yeah. So it is saying pip install Pydantic. Yes. Pip install Pydantic. Yeah, perfect. They actually have not provided something to validate if it is installed or not, because usually other libraries provide like something called as -v, blah, blah, blah. If you already know, just let me know if we have something for Pydantic, but it's fine because we have so many ways to validate it. And we have seen that we have this particular in the library. So fine. So now what we're going to do, we will create our file here, and let's actually create a file. Earlier I was thinking let's create a notebook, but it's fine. Let's create a file. Okay, so I'll simply say basics.py. Okay, or not just basics. Yeah, basics. Okay, perfect. So this is basics. So let's import Pydantic, and not Pydantic, from Pydantic import base model. Now what is this base model? This is, you can say, base model as well. Then we also need to import field, and that's it. That's it for now. And you, bro, just snooze. So what is this base model now? Remember I told you how we usually create classes and how we import the classes? There was a reason behind it. Okay, that's why I just covered classes in the beginning. So you can treat it as, you can say Pydantic is your class. Okay, Pydantic is your class, and you are importing this, not like Pydantic is the class. Pydantic is basically a module, and from where you are importing base model as a class. Base model as a class. So Pydantic, here you can feel that Pydantic is basically a file which is sitting inside your this particular working directory. Okay, makes sense. And within that Pydantic module, within that Pydantic package, you have a class called base model. That's why we downloaded this package called Pydantic. So whenever you just download any package, that means you have access to all the classes like this, base model and all those things which are built there. If you want to read more about this, simply click on control and then just click on this particular button. It will open this class. So see, class base model, meta class is this one. So it has so many things. It has model config, tool, signature, all these things. By the way, just a quick question for those ultra pro developers. What is this like double underscore? What is this? This is actually called dunder. Okay. And we have so many things, type checking, slots, and all those things within this particular class called base model. We have so many decorators, we have so many class methods. Anshlamba, do we need to understand this? No, not really. Okay. So now, this is a class which is called base model, and we can create our something called as Pydantic models. Okay, what are Pydantic models? Don't worry, listen to me carefully. Basically, have you ever tried writing something like this? X equals 10. Yes. Okay. What is the data type of X? The data type of X is integer. Makes sense. Have you ever tried writing something like this? X equals to Anshlamba. Obviously, why would you write my name? I'm no one, by the way. So let's say your name, your loved one's name, family member's name. So let's say X equals to Anshlamba. Anshlamba is not anyone's. Let's say Y. Okay. So Y equals Anshlamba. Okay. So have you ever written something like this? What is the data type of Y? Okay. The data type of Y is string. Okay. Makes sense. So far so good. Very good. Let's say you want to write something like this. Variable. Okay. Within this variable, you want to create multiple variables. For example, X equals to 10. Okay. Y equals to Anshlamba. Makes sense. Okay. Now, X is an independent variable. Okay. Y is an independent variable. What if I want to create a variable, let's say variable, which will hold these two variables? Okay. Which will hold these two variables. Okay. Makes sense. Okay. You will say, Anshlamba, I have a quick idea. What? We can create a dictionary. Very good. Very good. Good idea. Let's say X equals to 10, Y equals to Anshlamba. Okay, very good. Good idea. And this way we can store multiple variables, right? Is there any way I can validate this particular variable? What do you mean? Let's say I want to use this variable and I want to make sure that you will be using X equals to 10, not like 10. That means you will use integer data type for X and string data type for Y every time. You cannot write like this. Let's say this. Can you validate that? Obviously no. So that's where Pydantic comes into the picture. It can literally validate each and every variable that you want to use. Oh, and this particular parent variable name is called Pydantic model. See, whenever you learn new thing, okay, you need to understand one thing. Naming convention will definitely be different. But do you know what? Core understanding, core functionality will be the same. So Pydantic model was a very fancy name, but I just replaced this with a parent variable, you can say. So now this parent variable is equivalent to your Pydantic model. So I can say, where is my Pydantic model? Obviously it's not a Pydantic model because Pydantic model syntax is different, but you can treat it like that. Make sense? Very good. Now let's create our real Pydantic model. So how we create Pydantic mod? Bro, 5 minutes are over. Wow. Okay, sorry. So now what we need to do, we need to create our Pydantic model. And let me just tell you, each Pydantic model is basically a class. Oh, and within that class, we define the variables one by one. Okay. So for like this, I want to create a Pydantic model, which is called input. Okay. So what I will write, I will simply say class input. Okay. Now I cannot start creating my variables into this directly. No, I need to inherit base model. I need to inherit base model like this. Now I will create my two variables X. Okay. But I will create X. Very good. What will be the data type of X that I want to, let's say, define? I will say integer. Make sense? Okay. And Y will be string. Make sense? str. This is my basically the Pydantic model. Okay. So now what will happen? If I want to, let's say this is my input. Pylines are detected, bro. So let's say I want to use this particular model, which is a parent variable. If I will define or let's say pass anything different from these data types, it will throw an error. That is called validation. Okay. That is called validation. That is one part of it. Let's say you want to make sure that the data types that you are passing, you also need to parse it first of all. For example, in your function, in your anything, wherever you are using this input variable, you have defined that my data type is of input type. Okay. Now, before parsing the variables, basically before like let's say assigning the variables, you can even use this model to parse your variables. Okay. I know these things are very, very tricky. Don't worry. Just listen to me and just be with me. You will understand everything. And it's, I would say, important if these are tricky to you. That means you are learning something new, right? So that's a good thing. Okay, very good. So now what we need to do, we need to simply say integer and string. That's it. Okay, that's it. And now we have also imported this particular command. It's called field. It's called field. And by the way, there will be an equals to sign, I guess. And then we will simply say like this string or like this. It's fine because I was thinking like, should I just tell you about field as well, but it's fine. It's an easy one. So basically what this field will do, field can actually hold a lot of information. Whenever we define any kind of variable within our model, we always give a quick description. Why? You will understand like why it is important, because in the world of AI data engineering, you need to give some context. Okay. So description we always give. Second thing, we can specify if this particular variable is required or not. Oh, so we can even say if it is optional or not. Exactly. Third thing, we can also define some default values. Oh, so let's say there is a user who just passed this value y but didn't pass x. It's fine. We can even define the default value for this. This is amazing. This is next level validation. I know that. That's why I'm covering this concept in this particular video. So let me just show you welcome to Pydantic and get started. And if we have a very good example, otherwise I have to use my own examples. Okay. Class C. This is a good one. So they have also used a class which is called user. In our case, it is called input. Okay. And they have inherited the base model. Make sense? ID is of int type. Make sense? And then name is of string type. Make sense? Now, do you know what? There is a command. Let me just click on this plus button. ID is of type int. The annotation only declaration tells Pydantic that this field is required. String, bytes, floats, or will be co-erased to integers if possible. Otherwise, an exception will be raised. What is this thing? This is one of the good features about Pydantic. Okay, because Pydantic is not very, very rude. It's rude, but it's not very, very rude. So what is that thing? Let me just show you. So basically, let's say you want to define something such as, let's say you want to say equals to field. Okay. And inside this field, you need to say, hey, this field, this particular X variable is required. You will simply say ... Yes. This is the syntax. If you say ... that means it is required. Okay. One thing is this. Then you can also define something called as description. Okay. And in order to, description is not mandatory. You can skip it, but it's always good if you just define the description. Make sense? Very good. So far, so good. Okay. Let me just add a description and I can simply say description. This is X. This is not a good description. You can say this is X. Makes sense. Makes sense. This is X. Because in reality, you will be using a good example. Let's say this is X, like Y we are using X. And let's say this is the description, this is Y. Makes sense. So X and Y are required. Okay. Makes sense. So far, so good. Just remember, just take notes. This is for required. This is a quick description. Makes sense. So our X and Y are ready. Okay. Now is the important step. And bro, snooze. Very good. Now let's say this is done. This is done. Now what I want to do, I need to simply create a function. Or even before function, let me just show you how you can just parse the things. Okay, let's go step by step, Anshulamba. So now this input, which is a Pydantic model, is created. Okay. Now, how you can just use this particular Pydantic model? How? So you will simply say, let's say pyd input. Okay, pyd input, and you can create an instance of this particular model input. Now within this input, you need to pass these two variables, x and y. You can simply say x equals to, let's say 10, y equals to Anshlamba. Now this Pydantic input is the format that will be used in your functions or wherever you are using this data type. Make sense? It will make sense. Just be with me, because this part is like a borderline where you are just almost trying to understand and almost understanding it, and before that as well. So it's fine. So x equals to 10, y equals to Anshlamba. Make sense? Okay, Pydantic input is ready. Do you know what? If I just now print Pydantic model, Pydantic input that we have just created, what will happen? Let me just show you. So what it will do, it will take your values that you have defined here, x equals to 10, y equals to Anshlamba. Okay. And before returning the result, it will validate it. It will say, hey, x equals 10. Is it of integer type? Okay, it's good. Okay, y. Is it of string type? Very good. Both values are there because both are required. Very good. If all the checks are passed, only then this particular variable or basically instance will be created of this particular Pydantic model. And then only we can use this particular anywhere. And here I'm simply printing it, and we'll be just using in functions as well. Don't worry. So this is the way. Make sense? Let me just run it and let's see. So here what I got, x equals to 10, y equals to Anshlamba. That means it is working fine. That means this particular input that we have provided, this one is fine. Do you know what? What if I provide something like this? Let's say by mistake, I provide something like this. Anshlamba here as well. Let's say, okay, makes sense. Do you know what will happen? It will simply fail it. See why? It is saying, bro, I am expecting an integer type and you are saying Anshlamba. What is this? What is this? This is not allowed. So now I need to simply say 10, otherwise it will fail it. This is a validation step. But let me just show you one more interesting stuff that you just read on the documentation. What is that? If I pass something like this, what will happen? Just do let me know in the comment section right now. Let me just tell you what will happen. So it will work. Anshlamba, now we are confused. Bro, see, hold on, take a deep breath. Breath, take a deep breath. Let me just tell you. Basically what actually happened, or basically what actually happens whenever you use Pydantic, if Pydantic can convert your any input or any kind of thing that you are passing, it will try to convert. It was able to convert string 10 into integer 10 because it was able to convert it. Okay, but obviously it cannot convert Anshlamba into 10, so it failed it. So by default, Pydantic is, you can say, not that much rude. So before throwing an error, it tries its best to convert the data types on its own and not throw any error. This is interesting. But sometimes you need to say, I want an error for this as well, because my pipelines are very critical. I cannot take any risk. Okay, we have a solution for that as well. Then you can simply use something called as strict int. Okay, if I use here strict int, perfect. And if I run this now, it will throw an error. Why? Because now I'm saying, hey, you are a strict int. So this is basically a strict mode. So for every data type, we have a strict mode. We have strict int as string as well. See, string bool, string float, everything. We have everything for strict mode as well. Make sense? Make sense? Make sense? Make sense? I hope it makes sense. Okay, now Anshlamba, this is fine. This is fine. And before that, I also want to show you one more way. This is like one way of creating it. Okay, like this. There is another way to create or basically pass the variables. It is in the form of dictionary. So what you can do, you can also pass like this: x equals to 1, y equals to Anshlamba. Okay, and you can simply open this particular dictionary, expand this dictionary like this using double stars. This will also work. Choice is yours, whatever you want to use, because sometimes if we have so many variables, you cannot say x equals to this, y equals to this, z equals to this, blah blah equals to this, blah blah equals to this. It is always better to use a dictionary, but whenever you use a dictionary, just expand it using these asterisks, double asterisks, because it is equivalent to x equals to this, y equals to this, because it expands your dictionary. Make sense? I can even show you if you want to see. If I print this one, what is this? Okay, perfect. Let me just show you. And print. Oh man, what? Let me hit escape. Okay, perfect. So, okay. And this is obviously because you cannot expand it like this. You need to just pass it in the, you can say, class, then only it will expand it. So it's fine. But you can just understand like both are equivalent when you just say x equals to 1, y equals to 1, or you just expand it like this. Make sense? Make sense? Make sense? Make sense? So this is the way that you create it. Now let's see like what is the use case of it. Like we got to know like, okay, this is the way, like we just do these things, but what is the use case? Let's say in your function, let's say you are creating a function def, let's say main, let's say main. Okay, let's say main function. Within this function, you want to get two variables. If you would not be using this Pydantic class, you will be writing something like this: x equals to integer, y is of string type, right? And this way you will be just writing so many variables. This doesn't make your code look good. Plus it will not perform any kind of validation as well, because this is just like type hinting. It is not like strict rules. Okay. So here you can use this Pydantic model. You simply say, let's say variable, or let's say parameter. Okay. Para1. And this is of which type? This will be of input type. Oh, because now this has become a data type on its own. Now input is of input is itself a data type. So whenever you create a Pydantic model, that means you are creating a data type, customized data type, in which you have so many variables of different data types. That is your own personal data type. You can even write Ansh. Let's write Ansh. That means you want parameter of Ansh type. Okay. Let me write Ansh. Make sense? Okay. So now I do not need to worry about x and y. Why? Because I know that this function will only receive the parameter value if it will be of this particular data type. Make sense? Okay. And you cannot pass the values directly. What do I mean? You cannot simply say like parameter equals to this. No, you cannot do that. You have to pass the values. Who is calling me? So you have to pass the values using a parser. Using this. This is basically the parsing. This is basically the parsing. Because you are first creating an instance of this particular, you can say, Pydantic model, and then you are using this as the input. Make sense? Why this is important? Because you can obviously, let me first complete this. Let's say print hello Anshlamba. Let's say this is your function. Okay. Makes sense. Now let's call this function. So in order to call this function, you will write something like this: main, and then obviously data types. Now you have two options. Okay. And I will just show you both the options. First option is you know that x is of int type, y is of string type. So you can simply say x equals to 10, y equals to, let's say, Anshlamba. Okay, makes sense. Let me just run this and you will see hello Anshlamba. Now, Pydantic, okay, input takes no arguments. Okay, makes sense because this was renamed Vedansh. Perfect. You will see error. Wow, this is the thing. It is saying main got an unexpected keyword argument x. Yes, this is the thing. Now you know that in your Ansh data type, basically para 1, you have x equals to 10, y equals to Anshlamba. But even you know this, you cannot parse it like this. Why? Because this function is expecting para 1 as your data type. That's it. Oh, this is expecting para 1 is of your parameter of Ansh data type. It doesn't know like x equals to 10, y equals to Anshlamba. It doesn't care. It just needs one parameter, para 1, and is of Ansh data type. So how you can just pass that? You first need to create an instance of your Pydantic class. Oh, so you pass those values in your Pydantic class, then it creates an instance of it and you pass that instance. Let me just show you. You will simply write pyd object, basically pyd input. Now you will see it will work. See, hello Anshlamba. So what we need to do every time, you first create a data type, Pydantic model, okay, whatever fields in that we have, you create an instance of it. Basically this is an Pydantic instance, Pydantic model instance of your data type, of your Pydantic model, and within that model you pass all the values. Then this instance itself is being parsed in all the things, in all the functions. See, para 1 is of Ansh data type. Ansh data type means a Pydantic model, so it knows Ansh data type means Pydantic model. So Pydantic model obviously would receive Pydantic data type, and Pydantic data type is this one. Oh, this is like very fundamental stage. Okay, we need to cover a lot of things in this Pydantic class. This is like very fundamental area, because you need to make sure your data types are valid, are accurate before proceeding further, because it can break so many things, right? Okay, what if I do not define this value, let's say required. Let's say I remove this particular step. Okay, makes sense? Makes sense? What will happen? What will happen if I do not write like this? So if you do not write any kind of stuff here, you do not need to pass this thing and it will work. Okay, let's see. Okay, type equals to missing, x equals to 1. So what did we do here? What did we break? What did you break, Anshlamba? Wait. Okay, x equals to 1. That's fine. That's fine. Okay. I can simply pass a default value, by the way, even if it is not required. Or I can remove this as well, like field. And let's run this. No, field required. No, it is not required. Okay, input value x1. Okay, input type dict. Makes sense. First of all, let me just remove this. X equals to 1. That's fine. That we are providing. Okay. Pydantic input is also fine. Okay. Okay, makes sense. We can just provide default value. Now it's best time to talk about it. Let's say its default value is also Anshlamba. So now what I'm gonna do, I will not pass this value here. So what it will do, it will automatically pass this value in this particular Pydantic pyd input, and it will pass this value to this particular function, and that's it. Okay, and now if you also want to see the value of print pyd input, I can show you. So if I see the value, you will see x equals to 1, y equals to Anshlamba. Why? Because this is a default value. This is what? This is a default value. That's how you just pass the default values in your Pydantic class. Okay. And as I just mentioned, this is like very basic, very fundamental thing. And we're going to just cover a lot of things, but this is your base. Once you understand this, once you understand that, let me just quickly recap it before jumping on the advanced topics. You create a Pydantic model in which you define each variable, string type, integer type, required default value, so many things. Simple, sorted, very good. This is clear. Now you create a function. Okay, this is number one. Okay, this is number two. You create a function. Okay, you create a function and define that I want a data type of Ansh data type. Makes sense. You describe this of Ansh data type. Makes sense. Then if you want to call this function, you need to pass something for this particular parameter, which is of Ansh data type. What is Ansh data type? Ansh data type is of Pydantic model, this one. And in order to pass any Pydantic model, you need to create a Pydantic instance. So you will pass all the values to this particular Pydantic class, and what it will do, it will validate it. Is x of 1 like an integer type? Yes. Y? Okay, it's fine. Once everything is fine, this will create an instance, and this instance will be used to this function. Make sense? I hope now it makes sense. Now let's see some advanced topics in Pydantic, and don't worry, I am with you, bro. I will just make you understand everything. Just be with me. Okay. So now let's talk about some more things into this particular variable type. So how we can just work more with field. Okay, let's create a second file and I will call it as, let's say, fields. Okay, fields.py, because we want to talk more about fields, like how we can just work with, because this was like very simple example. Same import Pydantic, or from Pydantic, import base model and field. That's it. Okay, so now what I will do, I will create a model of, let's pick a very good example. We can say personal data type. Okay, personal info is a better name, and we need to import base model. Makes sense. Now what we need to do, we need to simply create 3 columns in that: name, age, email ID. Yes, these 3 things. Okay, name, age and email ID. Makes sense. So now what I will do, I will simply say name is of string type. Okay, and this is a field. This is a field, I know, and this is required. Make sense? And in the name, you cannot have name less than 4 characters and more than 20 characters, because this is my requirement. Let's say, okay, I know like name can be of 3 alphabets as well, but let's say it should be greater than or equals to 3. Okay, so we have these particular validation steps as well. You can say validation within validation. First it will check if it is of string type, then it will check the length as well. Yes, this is the power of Pydantic. It is not just made to check your data types is of string type or integer or not, bro. It will first check it is of string type, then it will check other things, then other. Amazing validation library. Okay, that's why I'm covering this specially for you, especially for my lovely data fam. So how can I just say that? I will simply say GE. GE means greater than. So that means greater than should be 3. Okay, and less than should be 20. Make sense? Okay, and obviously description. This is the name. Make sense? Make sense? Very good. So greater than 3, less than 20, and description is this is name, and this is actually required because we need name. So that is why we have defined 3 dots. Let's create age. Okay, and I want to say age of integer type. Okay, and this is also a field, and this is also required, and this should be greater than 0, because there cannot be an age less than 0, right? Okay, so greater than 0, less than, you can say 100. Why? There can be people more than 100. Okay, less than 1000. Then there can be people like more than 1000, bro. Let's say greater than 0. Okay, I'm not putting any upper limit. Greater than 0. Okay, simple. This is the age. Okay, description, this is age. Perfect. Makes sense. Okay, now, and let's make this particular column as optional. Oh, how we can just do that? It's very simple. You simply need to say, you simply need to add this pipe. Okay, you simply need to add this pipe because this is optional. This is optional. Make sense? And what is this none? None is basically the default value. I know the syntax is pretty weird, but yeah, it is what it is. And there's actually another way to do this. You can also write something like this: optional and then integer, like this as well. Like this is another way to write it. Okay, and in order to do that, you need to first of all import optional from here. Not I think from here. I think from typing. Yeah, from typing import optional. And by the way, we're gonna use some amazing data types from typing as well, because typing is an amazing library. Amazing. Okay, this is basically provide you this provides you like a set of data types such as list, dictionary, all those things. Okay, so I'll simply say dict any and then list. Okay, because you're gonna use those things. Perfect, 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 perfect. Make sense? Okay, good. So this is all about this one. Optional is also done. Okay, and by the way, I like that particular way to define it. Okay, perfect. Okay, perfect. Makes sense. So this is also done. Now I'm going to define email, which is not optional, by the way. So I'll simply say this is of string type. Okay, this is of field. Okay, and this is email. Do you know what I'm gonna do now? You can say that email, some people can just put something wrong in email ID. Maybe they are not using @. Maybe they are not performing all those steps like adding domain. So how we can just do that? Because this will only check string. Makes sense. There's a good news for you. Pydantic knows that email is such a critical area that you need to perform those checks manually. Okay, and it says you do not need to perform anything manually. Simply import one data type. It's called email string. Okay, and you can define that email string. What this particular data type will do: email string is a special data type which will check if you have the @, if you have the domain name, if you have all those things. So this is like live sorted data type. You do not need to worry about anything. Okay, so this is the email. Make sense? Now we gonna define some more things. More things can be, let's say, first of all, let's define let's say gender. Now you know that in gender we need to just put three things: male, female, and other. Okay, so obviously it is a string data type, but string can be mailer. If it is male, yes, someone can say mailer, right? You need to make sure that you will pick the value just from the accepted values basically. So for that we have an amazing data type. It's called literal. For like literal values, literal. Okay, so obviously I will just pull that particular data type from here, literal. Okay, and how I can just do that: gender, okay, literal, and then male, female, other. That's it. Makes sense? Make sense? Okay, that's how you define the accepted values. Accepted values. Make sense? Now someone cannot say mailer. Okay, they have to write like male. Make sense? Okay, now very interesting thing, very interesting thing. So now we need to pass a kind of list. Let's say there is area of salaries where they can, where the person can put his or her salaries. Make sense? Any salary basically. Okay, so in that particular scenario you can simply say salaries. Okay, salaries, and it will be list data type and list of integer. That's it. This is the way you can define the salary. So what will happen? You would have to pass the list of your all the salaries. Oh, okay, makes sense. So this is the way that you can just combine all of these data structures, basically data kind of data structures, and yes, you can say with Pydantic model. So this is the way to do it. Okay, you can even pass a dictionary of string values as well. Dictionary of string values, yeah, like let's say list of dictionaries basically. Let's say you want to simply say, hey, I want to just simply provide all the company names in which I have worked, like all those things, like company, location, and all those things. So it can just do that as well. Okay, it can do just that as well. So this is the way, by the way, and I know there are like so many information for you. Don't worry. So this is your data type. Okay, let's create a function. Okay, and I will simply say main, and it will use para1 of personal info type. Okay, and it will print all the information. It will print, let's say, name, para1 dot name. Okay, and like this it will simply put all these things. It will print all the values. Make sense? Now we know that in order to basically call this function, we need what? We need para1 of personal info data type. What is personal info data type? Personal info data type is a Pydantic model. And how we can just pass the Pydantic model? We first need to create an instance so that it can validate all the information that you are just passing as right or wrong, right? So let's create the instance. Let's say Pydantic instance, personal info, and just pass the dictionary like this. And yeah, perfect. And by the way, hide it, hide it, hide it, hide it. Okay, so perfect. This is my particular values that I'm passing. And what it will do, currently it will validate all the things. It will pass this dictionary to this particular Pydantic model, and it will check if I am passing all the values of the right data structures. And by the way, who is 20 years old, bro? I'm just, what's my age? Why should I tell you, bro? Oh, bro, it's not a big deal. Yeah, that's my, like, I just turned 25 this month. So if you don't know my age, now you know. 25, 25, 25, 25. Okay, so this is the Pydantic instance. Let's actually first of all print it. Okay, we are just seeing the values that we are passing here. If we have any errors, yeah, we have some errors. So what is this? Import email validator. Email validator is not installed. Oh, we need to simply install this as well. Okay, and I do not want to install this, by the way. Should I install it? Let's install it. Okay, let me say dot .venv dot scripts, then activate. Okay, then let me just add it, pip install pydantic email. Perfect. Let's install it. Perfect, done. Now we can just use it. Bro, we just downloaded it. Maybe we need to just restart the terminal. Sometime it takes time. I just downloaded it. Pip install Pydantic email. Let me just re-download it. That's why I love UV. Oh man, I'm missing my UV. First of all, let me just check what are the libraries that are installed on this particular package. So how we can just do that? Pip freeze, then requirements.txt. Perfect. Let's see. Let's write it here. Pydantic email. Okay. And now what I will do, I will simply say pip install. First of all, let me just activate the environment. Perfect. And then pip install -r requirements.txt. Already satisfied. Okay, so then just tell this compiler to run my code. What is this, bro? Email validated. Oh man, there's like, I'm so sure like there's import email validator. Are you serious? I think there's a dependency for email. I'm so sure there's like another package that is not. Email validator is not installed. Pip install Pydantic email. Oh man, I think I just need to restart my kernel. Wait. I don't know why this error is coming again and again, because my package is already installed. As you can also see, requirements.txt has email validator, and I don't know. So what I can do, I can simply try running the Python file directly from terminal instead of debugging it, because maybe this debug is not using my virtual environment. That's why I love UV. Oh man, UV is so lovely. So now I will simply say Python, then dot, then chapter 4, Pydantic. Okay, within that I have two fields.py. What is this? No module named Pydantic. Oh man, let me first of all pip activate, and then I can say this. Okay. Oh, this time is a new error. Unable to apply constraint. Very good. Very good. Very good. So it is saying I cannot apply GE. What is GE? See, it is saying unable to apply GE to supplied value with anshlambacollab. So instead of GE, we need to use GT. Why did we use GE? I don't know. And we need to use LT here. Okay. So now let's rerun it. Let's rerun it. Okay. First we need to activate it. Pydantic always activate, oh sorry, UV always activates our environment, you know. Okay, unable to apply constraint GT to supplied value anshlambacollab. What? This time is something else. Wait, supplied to value X. Okay, unable to apply constraint GT to supplied value X. Let me just check the code. Okay, name string makes sense, and name is anshlambacollab. Okay. Okay, less than 20. 1 2 3 4 5. Yeah, this is less than 20. Okay. Oh, I got it. It's just a silly mistake. I was like, what's wrong? So basically, what is greater than 3? It is not directly greater than 3. It is like min length and max length in string case. I was like, what's wrong? So silly typos, it's fine. Min length is equals to 3. Max length is 20. It's not GT or this one. And this is like GE. That was fine. So I simply checked it and I was like, what's wrong? So the wrong is this one. Like we cannot use GE or GT here. We have to use min length and max length. Okay. So now let's quickly check it and let me just correct it. So what I was doing, I was just simply testing it. Maybe this is the issue, but this was not the issue. Okay. So let's rerun this thing and activate it and run this. So this time it worked fine. Perfect. See? Perfect and amazing. So now what are we gonna do? We can simply call our function, which is called main. Okay, and we can not store because we are just simply printing it. So let's run this code. Environment activate and then Python. Perfect. We got the result. Boom. So that's how you work with the fields command, so that we can just validate all those things. Make sense. I hope it makes sense, and I hope it was like helpful. Okay, makes sense. Very good. So now it's time to go a little bit more in detail about some validation, more validation. Yes, Pydantic is all about validation. Let's see what do we have next. So now it's time to talk about some more advanced, I would say, validation now in Pydantic. You will say we have already performed so much of validation. Can we perform more validation? Yes. Pydantic is all about rules, validation, data checks, and I think more you will learn about these things, more proficient, and you can easily stand out in the crowd, because these things are like very advanced things, and these things are really new. That's why like it is a kind of hidden things that if you learn these things, you can actually stand out, because I am so sure everyone writes Python as a skill in the resume. Every single person, let's say 99.99999%. Now just tell me one thing, how many people write Pydantic in their resume? You will say hardly 10 to 20%, because this is a kind of hidden thing. And whoever is taking your, let's say, interview, the person would know about Pydantic, because in the industry we cannot actually build any kind of solution without Pydantic right now. Obviously, like we can, but people are not building anything without Pydantic because Pydantic is such a strong library. So if you write Pydantic and on top of it you explain how you have used Pydantic, validation, all those things that I'm just going to tell you about, field validation, model validation, if you write these things, that is the catchy point. That is the catchy point. And do you know what? It literally takes a lot of efforts, a lot of time to create these content. So just appreciate if you are gaining some knowledge from these content. Your one single tap on like button, your one single line of comment actually means a lot. You don't even know this. So if you are feeling that you are learning these things which are actually helping you to grow in your career, and whatever you are feeling, just appreciate it. That's all I can just say. Okay, so now let's create our third Python file, and now we're gonna talk about validation. Okay, validation. Let's talk about field validation first of all. And if you need these files, I will just upload these files in GitHub repo. Okay, so obviously like this is like very basic you can say files that you can also create while watching this video, but sometimes let's say you need to just use it for the reference because it is like much structured and in the chapters form. So I think it can be like handy for you. If you want to refer it, I will just put it in the GitHub repo. Don't need to worry. Okay, but I would encourage you to create your own notebooks, own you can say Python files, but yes, I will just put it in the GitHub repo so that you can just refer. Make sense? Okay, very good, very good, very good, very good. And obviously this is like advanced Python, so all the advanced topics will be there. Make sense? Okay, good. So now let's talk about the field validation. Now what is this field validation? What is this field validation? So basically, and if you need actually the whole repo, I can also paste it because I have requirements.txt. So if you need to just install it, because obviously these things will not be running if you do not have these libraries. So what I will do, I will also upload this requirements.txt. Okay, and I will simply add one readme file where I will just paste all the you can say steps that you need to perform. Sorted? Good, very good. So don't need to worry, I will just take care of that thing. So now let's talk about the field validation, and let me just close all the unnecessary tabs. Okay, perfect. So now what is field validation? If I just open fields tab, we already have some validation, right? Minimum length, maximum length, greater than, literal values. These are validations, right? Because we are validating the fields. We can even perform validation and we can literally perform customized validation. Wow, sounds really, really fancy. Yes, so let me first of all copy and paste these modules and let me just hit enter. So what I'm gonna do right now, I'm gonna create a class for let's say let's say personal info. Okay, let's say personal info, and you already know that we import base model. Base model is the backbone of Pydantic. Okay, so within this, let's create simple you can say strings, like the string and field equals to this, okay, age equals to this, and email equals to this. Simple. And let's remove email for now. Let's say we are not using email string because this is a very good example of this, because we need to validate it in a customized way. Let's imagine we do not have email string type, we just have string type. Make sense? Make sense? Now obviously we have some amazing data types which are added, something called as email string. But let's suppose this email string data type is not there, and now if you want to validate that if your end user is putting the right form of email, if you have @ in your email ID, if you have .com in your email ID, basically it is not necessary that you will be having .com because it totally depends on domain. But let's suppose you are just accepting generic domains where we just use .com. So you need to create something on your own to validate these things. That's where the concept of field validation comes into the picture, because it's not just about email string. It can be literally anything as per your you can say company, as per your organization, whatever rules they want to apply on any field, on any column, anything, right? It can be something which is very, you can say, subject to a specific use case, which will be provided by the industry. Industry means like organization. Make sense? So how you can tackle this thing? So we have a class called field validator, like this. Okay, field validator. So what we need to do, field validator, let me first of all remove email string so that it will not keep on suggesting this thing. So now in the field validator, we create a customized function. Yes, customized function. And on top of this, we use this decorator. Basically, this is the decorator. Now, what is a decorator? This is like a fundamental thing in Python. So if you do not know, or maybe you cannot remember, decorator is like, you can say, which takes your function, decorates it and returns something else. Oh, that's the whole point of decorator. As the name suggests, it decorates your function. It takes your function, okay, and it decorates it and then it returns something else. And we just use @ this decorator name, and that's it. Make sense? Okay, let's do it, then you will understand it. So I'll simply say @field validator, and I want to apply this validation on the email column. So I will simply say email. Make sense? Now I can write my function. The function is this email check. It can be anything, okay? And we need to pass two variables. First is CLS, which is a class variable, okay? Basically class attribute. And then the second can be, let's say, value. Let's say value. Okay. Now what I will do, I will simply say if okay, not in value, or .com not in value, then raise value error, invalid email address. Make sense? Otherwise, it's fine. We do not need to do anything. And then what will be returning? It will return value. Simple. So what it will do, whenever we will be just passing email, okay? And let me just tell you a fun fact, because this is very important. This is a field validation, right? Field validator for email. Do you know what? Whenever we will be passing any value for this particular model, personal info, the values will always go to this particular field validation first of all. So it will not even go here first of all. It will go here. Make sense? So what it will, so this will run before your Pydantic validation rules will be running on top of your input. So this is the first step. So whenever we will be just providing email, it will simply take the email, okay? It will take the email and it will just check if we have @, if we have .com, if yes, then only it will return value. Otherwise it will return error. Simple, value error. Okay, makes sense. So let's see with an example. Let's say I want to create an instance of this. Let's say Pydantic instance equals personal info, age this, and email is ansh.lamba@example.com. We have @ and we have .com as well, right? So this is a valid email and everything is valid. So if I try to print Pydantic instance, I should be able to do this. Yes, name equals to this, age equals to 25, email equals to this. But what if, let's say, someone forgot to add @, and it can happen, right? So in that particular scenario, you have Pydantic. You have what? Pydantic. So it will throw an error. See, invalid email address. Wow, literally wow. So this is the way you can perform some validation on top of your fields, which is like pure customized. You can literally write like anything here, anything. You can even customize this value as well. Do you know how? What is a good example of it? So let's say if .com is not in value, okay, do you know what you can do? Let me just remove this, because in some web forms, what we do, we just ask to put the username. So when we just need to put the username, maybe person will not be using any kind of .com. It's just a customized, you can say, hypothetical situation. So you just need to say okay. So here I will write elif if .com not in value, then do not raise the value error, simply return value plus .com. Make sense? And else I would say return value. Simple. Now let's try this. This is like very hypothetical situation, but let's try this. And I'm writing here @ okay, but let's say I forgot to add .com, but I know like .com is very, very obvious. Okay, so what I will do, I will simply run this, and here it has automatically added .com for me. So you can literally add and customize these solutions as well, where you know like it is very obvious, okay, and person would have forgot to add .com in its value, like whatever values they are submitting. Make sense? So this is a kind of, you can say, adding prefix and postfix which are very, very obvious that you would like to receive. Make sense? Because obviously whenever you're just building data pipelines, you need to make sure like you are accepting specific values in your columns. Specific values, it can be anything, right? It can be literally anything. So that's how you can just literally work with these validation steps, and you can make sure like everything is there. And earlier, before Pydantic, people are using so many if-else conditions, so many classes, so many functions. That doesn't make any sense. You simply need to create this instance, and you simply need to create the value instance of top of this particular Pydantic model, and then pass that to your whatever function, transformation, whatever you are doing. But simply create this model so that it can simply validate it before just passing the values to the, you can say, your functions, whatever. Make sense? Was it helpful? Yes. Now we have seen field validation. So this way we can actually validate our fields. Make sense? Make sense. Now, let's say we want to validate the entire model. Oh, what is that thing? Entire model. So basically we have validated the fields, right? Yes, we have validated the fields, but sometimes we need to validate the entire model as well. Entire model. Yes. Entire model, like this, let's say this one, personal info. This is a model, right? If we want to just, let's say, validate the entire model. Okay. So in that particular scenario, we have another decorator, which is called model validator. So this model validator, obviously we are not covering it here. We will be just creating a different file. So let's do it there. So let's create a new file. It's called model validation. Okay, .py. Okay, makes sense. So now here we can simply import it. Okay, perfect. Model validate, perfect. And just a quick tip for you, it has literally written everything. Just a quick tip for you. Sometimes if you do not see these colors coming up, that means like your oh man, this suggestion, your, let's say, environment is not picking, or basically your code interpreter, code, you can say maybe VS Code editor as well, your IDE is actually not picking your virtual environment. So what you can do, okay, obviously in the terminal you can just activate it, but to get rid of it, you can simply click here. Okay, this is the environment tab. So what it will do, it will simply pick your default environment for this particular IDE. When I click on it, I will get multiple options. I have 3.12, which is recommended, and this is a virtual environment. Okay, because I have downloaded 3.12. Okay, I have other options as well. So this is like Conda, this is global. So if by default it will be picking this one, which is a global environment. So it can throw errors. Hey, I do not have Pydantic, I do not have this thing. So if it says this thing, just make sure that you are using your virtual environment as your interpreter. Make sense? Simple. So simply pick this, and it is also recommended. So simply click here and you will then see .vnv. If you are not seeing .vnv, if you're just seeing Python, that means your virtual environment is not actually attached to this particular file, or basically this particular code editor. Simple, quick tip. So now let's talk about model validator. Basically model validation, or basically model validator decorator, always runs after you have passed the values, plus Pydantic model has just checked all the rules. For example, let's create a class, or this time let's create login. Yeah, makes sense. Login, not login. I will say authentication, auth, let's say. Okay, and let's pick this from base model, and this can be a very good example for, or let's say API authentication, because being a data engineer or being anyone playing with the data, we work a lot with API authentication. It can be tokens, it can be JWT tokens, it can be basic authentication, it can be a lot of things, right? So what we can do, we can simply create a login, email and password. Okay, so you will simply ask for email. This is the email, this is the password, and let's say confirm password. Make sense? Now, oh man, now let's say this is your email, password and confirm password. Okay, and all the rules are checked, string. Okay, so that means these are passed, but now you need to create a model validator in such a way that you need to logically check the values. For example, you know that in the password and confirm password, you need to put the same value in both the areas. Make sense? Password and confirm password, you need to put the same value, right? So how you can just put the same value in both the things, because this is a string, right? This is a string. We do not know like what value you'll be putting inside the string, and we cannot put any kind of, you can say, logical validation here, because we can only say minimum length equals to 8, that's fine, but we cannot have, we do not have any kind of logical comparison setup here. And obviously this cannot be achieved from field validator, because field validator is used when you need to validate only one field. Model validator is a validator which can combine multiple fields and just validate the logic. Okay, so here what we need to do, we will simply create basically create a function. Okay, and I can simply say password validate, or basically check, password check. So now I will be using first of all decorator. It's like model validator. Okay, and what will be the value? There is no value for model validator. You simply need to say mode equals to after. Okay, mode equals to after, and here if you remember, we simply applied field validation on a specific column, but as I just mentioned, it is not just a validation on a field, it is a validation on the logic. So we'll simply say mode, not model, it's mode equals to after. That means we need to run this particular model validator after we have just passed all these checks. Okay, because only then you can compare the values, right? You cannot run this model before, because if it has not, you can say, validate if it is a string or not, how it can just validate this particular logic if password equals to confirm password? It will only validate this if it has the values for both the variables, right? Okay, makes sense. So here we'll be using CLS, and here in the password check, CLS is like again like your a kind of class variable that will be passing. Okay, makes sense. So here what we need to pass here in the password check, basically the model validator. So in model validator, let's say I'm writing here values. So what will happen in the values? It will simply pass all the variables in the form of a dictionary. Okay, that means the moment I write here values, that means it will pass all these variables, email, password, confirm password, and all the variables in the form of dictionary to this particular function as a parameter. Whereas in the case of field validation, it will only pass one column, and that column will be written here in this particular field validator. Remember, we write email. So that means we are simply passing only that particular field. But in case of model validation, we pass all the values, basically all these variables. Okay, and how we can just now access, we'll simply say if values dot email, okay, not email, here is password equals to, or basically not equals to, because we want to throw the error. So not equals to values dot confirm password. If this is the case, then raise value error, raise value error, and whatever you need to write, let's say password not matching, password not matching. Make sense? Otherwise it's fine, and you can simply return values, because you simply need to return the values. Make sense? So that's how you can just perform this thing. Now let's test actually. Okay, now let's create Pydantic instance, email this password, password123, password123. Let's try to print it. Okay, let's run this. Okay, so we got the password because both were same. Let's try to play with it. Let's say I pass 123, and in one case I pass 456. Okay, makes sense. Let's now test. It will throw the error. Why? Because it is not matching. Perfect. Perfect. So this is the way you can validate your logics as well in this particular area. Make sense? 1, 2, 3. Okay, perfect. So that's how you work with model validation if you just want to validate the logic of your model. Make sense? There is one more thing in this particular area, which is called validation. It is not a kind of validation, it is a kind of computation. If you want to perform some customized calculations, what do I mean? Let's say let's create a new file. There are like so many modules within this chapter. Pydantic is like actually worth it, because whenever you just learn more about Pydantic, we feel more powerful, because we know that we can perform validation, and validation is everything for your pipelines, for your programs, for your everything, for your basically orchestration, because one validation failure can just break the entire flow. So validation is like the backbone. Okay, so this is 5, and this will say calculated, or basically computed fields. Okay, .py. Okay, makes sense. So let's see what we can do with computed fields. So let's say you have a kind of APIs, basically KPIs, not APIs, KPIs. So what you can do with this particular thing, with the KPIs, let's say your pipelines, your orchestration, your workflows are actually performing some kind of calculation as well, that you do not want to get it from the user. For example, you have orders table, okay, and you just want to pass some more columns which are not present in the source, but you know that you can create those columns by performing some basic computation. For example, unit price into quantity. You know that you can just perform this thing by computation. So you can perform those things here as well. You simply need to import one more decorator. It's called computed field. Okay, computed field. Let me remove these two because these two are not required. Perfect, computed field. So how you can just create computed field? It's very simple. Let's say class orders base model, and here you will be using two decorators. The first decorator will be computed field itself, okay, and the other one will be property. Okay, now you can just perform your def. Okay, so def will be normal customized function. Let's say I will say calculated field. Okay, calculated field. And before even that, let me just define some variables. So let's say order ID. Okay, order ID is of integer type. Okay, and we can say equals to field dot description order ID. Okay, then we can say unit price of integer, okay, equals to field dot description unit price. Okay, now let's say amount integer equals to field dot description equals to total amount or just amount. Okay, amount per unit, let's say. Makes sense? Now you know that you also need to get one more column from the user. It's called total amount, which will be the multiplication of both the columns, unit price and amount. But obviously it's not user's responsibility to give you that particular value so that you can just make your work easy. You need to compute and you need to calculate these columns on your own. So here in Pydantic, you can also do this thing with the help of these two, you can say, decorators. So here I'll be simply creating a customized function that we create in normal classes with self as a parameter. So here I'll simply write, so just a quick recap. How do we use the attributes within the class? Using self dot something, right? So we exactly need to do that thing. We'll simply say return self dot unit price into self dot amount. Okay, makes sense. And here I will simply say total amount because this will be the name of my new calculated field. That's it. Okay, so now test it. First of all, Pydantic instance equals orders. Okay, and here you can simply pass a dictionary. Let's say ID is 1, then you have unit price, and then you have unit price, let's say 10, and then you have amount, unit price and amount, not unit price, it's like units. I was like, what? Units, perfect. So it's units now. Perfect. Units are 10 and amount per unit is basically, let's say 100. Okay, so the total amount will be 1000. So I need to see this Pydantic instance now. Make sense? Okay. Do we get error? To the missing annotation specifying return type. What it is saying, because we are already returning this particular, you can say, type, but it is saying I do not know the type of the return. So I need to just explain, not explain, I can just mention it, that the return type will be of maybe integer or maybe float. In this case, it will be integer. So I also need to give a hint to this particular thing using this type hinting. It is int. Make sense? I think now it should work. Let me just run it. Perfect. So why we are not seeing the values? Oh, because we didn't print it. Okay. Print, let's say Pydantic instance. Okay. Orders object has no attribute unit price. Who is saying unit price? Unit price. Oh, maybe we didn't save it and we didn't change it here. Okay, makes sense. Now let's run it. Okay, perfect. So see, this time we also got this third column as well, which is saying total amount. So even this column was not there in this particular model, but you calculated it using this computed field. So you just need to get these three values from your user, but you can also create the fourth column like this. Make sense? So here, let's run it for one more time and let me just show you the answer. 1, 2, 3, 4. See, so here we simply asked for these three values, 1, 2 and 3, and this fourth column was already created using our customized calculation. Make sense? Make sense? So you do not need to just get everything from the user. No, you can just create some computation or basically computed fields on your own as well. Make sense? Make sense? Make sense? Very good. So now let's talk about serialization, and just to save some time, I have just simply created two different classes, basically two different Pydantic models. One is input and one is output. Okay. So this is of input type, this is of output type. Makes sense. So now what I will do, I will simply create a function. Okay. And this will be, let's say, process data. And here the input, or basically let's say parameter input, is of input type. Makes sense. And the output will be of output type. Oh, so far we were only using Pydantic models to take the data, to receive the data. But now this time we want to give the output of the function in the Pydantic model itself, and we do this as well. Okay, and it is very useful when you need to just pass the values between the functions. Okay, so what we need to do, we will simply use the result of this particular query, and we know that whenever we just pass this input, we will get the query variable, right? And how we can just access it, I will simply say input query equals p input dot query. Okay, this will simply fetch the query from this particular Pydantic model. Perfect. And we know that in our output we have one more variable, it's called result. Let's say result is anything. Result is greeting. Let's say hello world or hello bro. Okay. So now I cannot simply say return result or return result comma input query. No, I cannot, because I want to, or I have to return the result in the form of Pydantic model. Okay. So what I will do, same thing that you do for data parsing. So this is a kind of data parsing, right? You have both the variables that you need in your Pydantic model. Now you just need to parse these values in the form of Pydantic. And how you can just do that? You got my point. You have both the variables. See, you have these two variables here that are required for these Pydantic. Now you just need to parse these two variables so that it will become a Pydantic, so that you can say that I have passed this value in the form of output. Okay, very good. So how you can just do that? Let's say Pydantic result equals, or basically Pydantic output. Okay, Pydantic output equals output and then dictionary. Dictionary is input query. Query, the value is input query. Perfect. And the second thing is result, and result is result. So now this will become a Pydantic model, right? Now I can simply say return Pydantic output. Perfect. Now let's quickly check and test it. Let's say response equals process data, and let's pass the data in the form of Pydantic. So I will say input query equals input query is, query can be, let's say anything. Let's say how are you? Perfect. How are you? Perfect. I will simply say input query. Perfect. So now let's print the response as well. So what I will get in the response, I will get a Pydantic model if everything is fine. See, this is a Pydantic model. This time it is not just like simple string, integer. No, this is a Pydantic result, Pydantic output. Let's say you want to return the result, obviously in the Pydantic model, but in a better way. Because usually whenever we just want to return the result, we need to return the result so that we can utilize it. Okay. Yes, you need to parse the result so that you can validate, okay, everything is fine. Your validation checks are completed. You have got this particular, you can say variable, which is an instance of Pydantic model. But now you do not want to return the result in the form of Pydantic model itself, because you want to return the result in the form of, you can say JSON or dictionary, so that we can use it in our further functions. Make sense? Make sense? Obviously, because now you cannot use this function, like output of this function. Now you have two options if you just want to handle it. My personal opinion will be you should parse the function value in the form of Pydantic itself. But if you want to use it, like let's say you want to convert this Pydantic object into normal consumable format, you should always convert your response. So what I can do now, I can simply convert this response. So I will simply say print response, which is the original response. If I want to convert this response, because this response is in the Pydantic format, because we are returning the data in the Pydantic form. But if I want to use it, I can convert it in the form of dictionary. So for that, I need to import one thing which is called model dump, or maybe it is already, like we can directly use it. Maybe we do not need to import it. So I'll simply say print response dot model dump. So what it will do, it is a kind of serialization. It will serialize it into the form of dictionary. Make sense? It is serialization to dictionary. Okay. And we can also serialize it in the form of JSON as well. Okay. So let me just add a line. Print. Okay. And if I say print Now, if you do not want to convert this data into dictionary, if you want a JSON string, you can also get it like this: response.model dump JSON. Make sense? So these are the ways to serialize your Pydantic models. So if I see it here, see, this is the Pydantic output, which is very good, but you cannot use this in your further processes. You can convert it into a dictionary, or you can even convert it into a JSON. I know JSON and dictionaries are like pretty much similar, but yeah, this is a string JSON. This is not a normal JSON. Okay, this is a string JSON. Okay, makes sense. Makes sense. So this is all about your serialization, and that's a kind of, you can say, your Pydantic crash course. Now I hope that you can just use this. A quick topic is left, and I do not want to leave you with any kind of you can say important topics. So I want to cover this as well. It is a quick topic. It is called inheritance E or A. I don't know. Just check the spelling. Inheritance. So let's say you have these two classes. It's a very quick topic. Don't worry at all. Okay. So let's say you have, let's make it real. Let's say this is address. Okay. This is address. Okay. And in the address class, you have created, let's say, street, city, zip code. Okay, you have already written these things, and now you are creating another Pydantic model. It's called personal info. Okay, personal info. Now in the personal info, obviously you will be defining these three things: name, age, and email, and you will also be having address. Now you will be writing these things again in your personal info class. Does that make any sense? Obviously not. But in Pydantic, it will say you can inherit your Pydantic models as well. So what we need to do, as you can see that in my address variable, I am directly using this particular class, basically Pydantic model, as my data type. See? So this time I do not need to specify or basically create these fields again. This is called inheritance in Pydantic. Now you will say, okay, this is fine. How will we just parsing this information in our models? It's very simple. Let me just show you Pydantic instance. If you want to create this instance, you will simply create it with the help of this personal info. Okay, and here you will be just passing all the informations, and this is the way that you will be just passing the information. Okay, so name, age, email, and for address you need to parse another, you can say, model like this: address, and then star and these things. Make sense? Make sense. This is how you just do it. And let me just print this instance just to show you. So if you just print it, you will find all the informations like this. See? So this is the way you can perform inheritance in Pydantic models. Now your Pydantic chapter is completed. I hope this was very insightful chapter, and I would say this is the favorite chapter, should be the favorite chapters for the data professional, because whenever we talk about data validation, whenever we talk about validation checks and all, data people are like, okay, it's our topic. Okay, so this chapter is also done. Now what's our next chapter? The next chapter is very interesting. It's called chapter 5, APIs. Whoa, see, APIs. In the world of AI data engineering, everyone is talking about APIs, but do you know what? Data engineers are the people who consume API the most, because software engineers actually create the APIs. Okay, and we data engineers are actually the ones who are using those APIs to pull the data. So in this particular chapter, we'll be just looking at how we can just ingest the data, how we can just pull the data, and how we can just make the API calls. I want to go deeper inside this topic because it is very simple. It is very easy to make the API calls using request module. It's very easy. But we need to also understand how we can just work with query parameters, all those things which are very important to perform pagination rules and all those things. Make sense? So I want to just talk about all those things. Okay, let's see what do we have in this chapter, which is called APIs. So now let's talk about APIs. So let's create a blank file, and I know that this is very important, basics.py. So basically API. Now what is API? Do you know what is API? API stands for application programming interface or program interface. Basically API is nothing but a kind of bridge between you who wants to just get the data and the one who owns the data. For example, you are a data engineer. Okay, you are a data engineer. Okay, and there is a data sitting here. This is the database. Ooh. Okay, so this is isolated, this is protected. Okay, now you want to use this data and you cannot use this data, because if you will be able to go inside this, you can say, database, you can do wonders, right? You can maybe like do so many other things. You will be having access to so many other databases that you should not, and there will be a chaos. So that's where the concept of API comes into the picture. It says who. So basically whoever develops this particular database, okay, so they will develop this API as well. So they will say, if you want to talk to us, if you want to just get this data, you can send your request with the help of this API. Okay, what is an API? API basically a kind of endpoint, or basically URL. Okay, so in this API application programming interface, there'll be like so many URLs. Okay, if there is one URL, that is equivalent to API. If there are like multiple URLs, they can just sum up and they can be called as API, or maybe so many APIs. Okay, so there'll be like so many URLs. Let's use orange color. Okay, let's say URL1, URL2, URL3. Okay, so they have these set of URLs. Make sense? These are basically the endpoints. This URL can point you to, let's say, table, or basically database 1, URL2 is for database 2, URL3 is for database 3, and so on, right? So you can use these URLs to actually reach to this particular database. Let's say this is database 1. So you will go to API and you will be having these URLs, and who will provide these URLs? These URLs will be provided by the API builder, because they know the path. We do not know the path. Okay, only they know the path. So we just use the path, which is like this URL. Basically you can make this arrow like this. Okay, so you use this URL, you go to this particular database. Okay, and how it will authenticate that you are the right person. You will pass some, you can say, authentication. It can be 2.0, it can be basic authentication. That depends, like whatever you are passing. If it is public API, then you do not need to pass authentication, because everything is publicly available. So this goes to this particular database and this sends back the request with an answer. It will say, hey, this is your data, and this data will be coming to me with this particular API. So API is the intermediate step, basically a bridge between you and the data that you want to use. Simple. Okay, and you know what? Everything is API. Whenever you just search on Google, right, you are actually sending the GET request to the Google server, and they are showing you the home page in the form of response. So everything is like request and response, request and response. That's it. That's it. Okay, makes sense? So API is like very broad term, but actually you are using URLs. You are actually using endpoints to hit that particular, you can say, whatever you want to use. When you write www.google.com, you are actually hitting a URL. You are actually hitting an endpoint, and you are getting a response and return, which is a homepage of Google, right? In this particular case, we are not handling front end. We do not need to see web pages. We need to directly see the data. So what they do, they return us the data in the form of JSON. So we directly see the data without any kind of URL, homepage and all. Simple. So this is like API. So let's say you want to fetch some data which is available in the database. And a very good example can be Pokemon. So basically this is a publicly available API, Pocky API. Okay, and you can simply go to Google and simply search demo API Pokemon. Okay, and this is the resource Pocky API. Okay, so this is the like very good example. Okay, because this will cover all the things that I want to cover. So this is basically an API, and as I just mentioned, that URLs will be provided by the API builder. So let's say this is the URL that you want to use. So whenever we will be just using this URL, and this API is basically publicly available, that means we can use this data. Okay, so we will just make this API request, and we want to pull the data using this particular URL. Make sense? Very good, simple, sorted. So you can also see, if you just click on this URL, let me not copy the whole URL. Let me just copy the URL, removing ditto. So this is the response I have got in the form of JSON. These are like single line JSONs, right? So these are the response. By default, we only get 20 response. And who decides these kinds of rules? API builder. Everything is in the control of API builder. You cannot actually do anything. So by default, we are seeing 20 records. Okay. So this is the scenario. Make sense? Okay. This is the scenario. Makes sense. So now this is the data that you want to, let's say, fetch. Okay. So how we can just fetch that? We have some libraries available in the Python. A very popular library is request. Let me just import that. Import requests. Okay. And why it is blue? Why it is blue? Request module is not accessed pylons. Okay. Maybe we need to add it. So let me just quickly add pip install. But I think this is a built-in library, right? If I'm not wrong. If not, we can download it, no worries. Okay. But I think so. Okay, we downloaded it, no worries. And let me just add it to my terminal as well, so that you can also download it. Pip freeze requirements.txt. Okay. Is it added? Request, where is request? Yeah, it's added. Perfect. So in order to just make this API call, I will simply say response equals requests.get. Now why get? Because I want to make a get request. Now basically there are 4 different types of request: get, post, put, and delete. Really? Yeah, these 4. Basically we just use get and post a lot. Data engineers, we hardly use put command because we do not want to modify any data on the source side. We are not responsible for that. And delete, we hardly delete anything on the source side because we are data lovers. We like to keep as much data as we can. So usually we use get and post a lot. Get method means we want to get the data. Post method means we want to get the data, but we want to send the data first, and you need to process it and then you will send something in return. This is post. Okay. Put, as I just mentioned, if you just want to modify the data. Delete means delete. Simple. So now what is the URL? So URL, I can create a variable for URL. URL is this Pokemon, only till Pokemon. Okay. I was not a Pokemon lover. Let me be very honest. I was a Doraemon guy. And Shinchan and Power Rangers as well. Yeah. But I never liked Pokemon. I still remember like 1 to 2 characters, Bulbasaur, and I think the boy name was Ash. It was similar to Ansh, so I don't know, like still I was not a fan of Pokemon. So response.get URL. Now I just need to pass the URL, right? So now if I just show you the response, what will be the response? Let me just show you what will be the response. Response will be almost nothing. You first need to convert the response in the form of JSON. So you will simply say response.json and you need to print it as well. Okay, you need to print it as well. And we usually call it as data. So let me first of all show you the response, because I need to use the right naming conventions. So see, nothing. And now, oh, nothing because you didn't put anything. Perfect. So now if I see it, response 200. What is this response 200? Basically, there are some status codes that we use, and these are basically the protocols. Status 200 means success. 40 means error. 500 means server error. So there are basically some status codes that we use. 200 means it is fine. That means we are able to hit that endpoint. We are able to connect to that endpoint. Perfect. So now we are able to hit to that endpoint. I will simply get the data. So data is equivalent to response.json. Because we need to convert that into JSON form. Now if I say print data, now you will see the JSON data. Wow. Literally wow. Very good. Amazing, amazing, amazing. But do you know what? Let me just tell you what. Because this is very simple. Let me just create an advanced file. This is very simple. You are able to get the data, right? Very good. Now let's create something called as advanced.py. Okay, import requests, and here I want to talk about query parameters because this is very important. So let's say this is your API that you are making a call to. Okay, by default, this API will give you 20 records. But you know what? There are much more records than just 20. How do I know? There are some things. See, count equals to 1302. Okay, these are like basically total counts. Okay, then we have offset, then we have limit, then we have this question mark. What is this question mark? So basically these are called query parameters. These are called what? Query parameters. So let me just increase the size. See, this is called query parameters. So that means you can actually add some where clauses, some you can say additional conditions whenever you make an API call, and you just add it using the question mark sign. And then you need to use the exact variables that are given here. Offset and limit. Okay, it can be different as per the API. Here we are seeing offset. Make sense? So here, do you know what? We can say offset equals to 20. What is offset, by the way? Offset in API are like, let's say this particular record, this particular response basically is showing you the response from 0 to 20. Okay, 0 to 20 because limit is 20. Makes sense. Now next time, if I want to, this is like page 1. If I want to go to page 2, I need to say 20 to 40. Very good. Then on the third page, I will be saying 40 to 60. Make sense? Simple dimple. So now this is your offset. If you want to go to page 1, your offset will be 0. If you want to go to page 2, your offset will be 20. If you want to go to page 3, your offset will be 40. So you need to get all the data. You need to get all the data with different offsets, and you need to dynamically pass these values. Oh, okay. Got my point? Simple. So in this particular situation, you need to make sure that you are able to get all the data like this. Makes sense. Makes sense. Makes sense. So see, this is a variable called results, and results variable is actually holding your data in the form of list. See, this is the one. So how you can just pull this data dynamically for all the records, and we are just assuming that we have total records as 1302. Make sense? Okay. Okay. So now we can do that. Let me just show you. So first of all, I will make the API call similar to this one. Okay. Similar to this one, and I will simply say data equals to response.json. Okay. But here I also want to say dot get, and here I will simply get the count. Okay. And I will just call it as total count, or basically total records. Okay. Makes sense. If I say print total records, perfect. If I print it, I will get what? I will get 1302, right? Perfect. 1302. These are my total number of records. So now what I will do, I will simply say for I in range 0 till total records. Okay, total records. This is fine. Now I want to jump my loop from 0 to directly to 20, not 1, not 2, directly 20. And next time 40, because our offset value is multiplication of 20, right? So I will simply say 0 total records and then 20. Make sense? So this is my, you can say, offset value. Make sense? So now I need to just create a dynamic URL which will be called as paginated URL. Paginated URL equals obviously f string. I will be using URL, which is the base URL till Pokemon. And after that, I need to use the query parameters as I just mentioned, and offset value will be I, and limit will be 20 because it is fixed. It is fixed by the, you can say, let me just add the limit as well. Limit equals to 20. So this is my paginated URL. Make sense? If I now say response requests dot get paginated URL. So what it will do, every time it will get my response for a new URL. Very good. Make sense? then obviously I'll be just converting that data into JSON, right? And I just want results, because results is the form that is actually holding the data, but that is optional. You can still store all the data. It's fine. It's fine. It's not a big deal. Okay. It's fine. Let's say I want to store all the data, but ideally you can just get the results. But let's say you want to store all the metadata as well. That is fine. Okay. Now this data will be holding your all the responses, and it will be making API calls one by one. Oh, and this will actually hold all your data. Make sense? Make sense? Very good. Let's say I want to store the results into a list. Let's create an empty list, and let's say all data is an empty list. I want to all data dot, I can also do append, but it's fine. We can also do extend. Okay, data dot get results, or we are saying just data, because I told you that we can just save the whole data with metadata. It's fine. Okay, so we want to just store all the data. Make sense? Make sense? So what it will do, it will simply extend this particular list with all the lists. So basically, why do we use extend and when do we use append? So let's say you want to just add the items to a list, you simply use append. Let's simply add it. But in case of extend, you need to simply extending your list. So for example, a very good example, let's say this is your list. Okay, this is an empty list. And in this list, if you are just appending the data, which is of also the list type, it will simply create list like this. Let's say 1, 2, 3, and then another list, then 4, 5, 6. So this is like normal behavior of append. But if we say extend, it will iterate over each element of the inner list as well, and it will just append it accordingly. So it will do like this: 1, 2, 3, 4, 5, 6. So this is the difference between append and extend. Okay, so when we use extend, we are hoping that we are getting the data in the JSON in the list format, but it is not actually list. So it is fine if we are just using append here instead of extend. So it's fine. But yes, we have to use extend if we are using data dot get and results only. But I just want to store everything. Okay, so this is the thing. Let's run this and let's print let's print all data instead of just printing the whole dump. We just need to see length. So here it has given me the length 1302. Very good. That means it has saved all the 1302. You can say list or whatever you can say. Make sense? So that's all about your APIs, and I hope this was helpful. Like now I know that you know that how to perform dynamically pagination rules, query parameters, and all those things. There are so many ways we can just perform pagination rules. It all depends like how API is configured and how it can handle the pagination rules. Offset and limit is like the standard way that will be always there in almost all the APIs. In some APIs, we also get the next page URL, which is called absolute URL. So that there are like so many ways, but you should have at least this understanding so that you can just work with APIs and you can just get the data. You can just fetch the data. For now, we have simply saved all the data in the list. You can also write this data in the form of files using, you can say with open file as this, and you can just write your data as well. Okay, that makes sense. Okay, so that is the end of this chapter called APIs. Okay, and I hope this was helpful. So now what is next? See, data people love data frames, right? And you would have also learned about data frames in the PySpark videos, in my project videos. Now we are covering Python. In Python, we also get a built-in module, not built-in, like obviously it is a package we need to install, but it is like supported by Python. So it is a Python library, pure Python library that we can use to work with data frames. And obviously you would know it's called Pandas. Pandas library is like purely a Python package, Python library, which helps us to work with small to mid-sized data frames. And being a data professional, you should know about data frames and how to work with data frames in, you can say, your Pandas library. So I will give you a quick overview of Pandas, how you can just create data frames, how you can just perform some transformations and all those things. Okay, and after that you will be able to just work with Pandas data frames as well. Yes, we work with PySpark data frames more, but you should have some familiarity, very basic familiarity with Pandas data frame as well. And let me just tell you, it's like very similar to PySpark data frame, and PySpark data frame is very similar to Pandas data frame. So both are like very similar. Don't need to worry. just like the behind the scenes computation is very optimized for PySpark. In Pandas, it's like not very optimized because it's not working with distributed computing. It's just like single node, which is like our computer, that's it, or you can say local machine. So let's create a new chapter called Pandas, or basically data frames. Okay, because obviously if you're just covering advanced topics in the Python world, we have to cover data frames, right? Because we cannot skip this data frames. This is very important. Okay, so within this, let's create, or before even creating this, I need to add that particular module pip install pandas. Perfect. So let's download the pandas. Perfect. And it will be just creating this pandas. One quick note, sometimes you will see errors while creating NumPy pandas packages. It can happen because you need something called as C++ development toolkit for your system. So what you can do, if you see that error, if you do not see, it's fine. Sometime you can see, if you see that error, you can simply download Visual Studio exe installer, not Visual Studio Code. This is Visual Studio Code. This is fine, but you need Visual Studio exe installer as well. That will help you to build your packages such as NumPy, Pandas, all those modern packages. Okay, so you can install that if you see the error. If you do not, it's fine. It's like fine. Okay, makes sense. So what I can do, I can simply say, and that's why I'm not adding this pandas data frame here in the requirements.txt, because I know it will add those NumPy modules as well. And the moment you will be just trying to installing it, you can see the errors and you will be stuck. So I don't want to do that. So I will just keep it as it is. I will not add pandas and NumPy here. Yes, you need to manually add this here. Okay, because it totally depends like which system are you using. Maybe in some cases you will already have that Visual Studio installer installed. In some cases people will not be having that. So that is why you can install it manually like this. Okay, it will not be automatically installed with requirements.txt. You have to write pip install pandas, that's it, and see if you see the error. If not, it's fine. Okay, perfect. So now we can create our first file. It's called basics.py. Perfect. So now in order to work with pandas, we simply say import pandas as pd, which is just, you can say, an abbreviation for pandas, because it is very common that we say pandas as pd. Now in order to work with pandas, we need a file, very common, you can say CSV file. So let me quickly upload a CSV file here. Okay, and I will just upload the CSV file within the same repo. You can also download it, and I will say, bro, just download any CSV file from any browser. Okay, do not be like, hey, just give me the same CSV file. This is like very demo file. You can just use any CSV file, any CSV file. Okay, so let me just add a CSV file here, and let's actually see how we can just work with that. So let me just add the CSV file within the same folder. Okay, so now do you know what actually happened just now? I recorded this whole particular chapter 6, and voice was not being recorded, and let me just check now. Now it is being recorded. So now don't worry, I will just re-explain. No need to worry. So basically, instead of creating Python files, I think we should just cover this particular chapter with the help of notebooks, because whenever you want to work with data frames, we do not want to run the whole notebook again and again. We should run the subset of code, and whenever we just need to run the subset of code, we every time work with something called as notebooks, because notebooks run your code in pieces. Okay, so how you can also, let's say, work with notebooks. So I have already created this notebook, these two, and don't worry, I can just show you how you can just create this one. Simply click on plus new file, and let's say new notebook.ipynb. That's it. This is your new notebook. If you are using, or basically if you have never worked with, you can say, notebooks, initially VS Code will ask you to download IPyKernel. Okay, or basically Jupyter Labs, whatever it will just prompt you, just click on install and just get it installed. Okay, after that, just make sure you also have this particular package installed. It's called IPyKernel. Okay, hit enter, and in my case it will be automatically there because I just recorded this. So you can also install it. Okay, very good. Then the second task is you need to select the kernel, and you can just pick the virtual environment, because in the virtual environment I have all the packages installed. Make sense? Very good. So now Let me just show you step by step what we have actually done. Basically this notebook is there, but I just want to recreate that notebook just for you so that you can just feel that we are just writing the code in a live class. Okay, so first of all, I will just import the module as import pandas as pd. Okay, and I can simply run this cell. And how I can just run this cell, I can just click on this button or I can hit shift plus enter. That's it. This will run my cell. Okay, very good. Now let's say I want to create a data frame using pandas. Okay, so it is very simple. It is very similar to PySpark data frame. You simply need to write df equals not PySpark pd dot read csv. Okay, and then you can just define the data, the path of your file. If that file is sitting in this particular folder, okay, you can just read it directly. But I want to show you some advanced scenarios when you just want to read the file sitting in the cloud using URLs. So you can simply use those URLs, or let's say in my case, I want to just read the data from my GitHub repo. Okay, so I can simply go here and I can simply grab this particular URL that you can also use. Okay, perfect. So this is my URL. Okay, now the moment I hit shift enter, it will create a data frame on top of this particular cloud URL. Okay, and in order to see the data, we do not need to write print, because in the notebooks, if I say df, it will automatically understand it that we need to print this, right? So I will simply say df.head and that's it. Why df.head? Basically .head is a function which helps us to print the top 5 records. That's it. You can also define 10 if you want more records, but by default it will take 5. Okay, we have head in PySpark as well. Okay, so it's pretty much similar, nothing special. So this way you can see the top 5 records, right? Very good. So now this is your df, the same way that you have df in PySpark. Okay, and let me just tell you, if you do not know much about PySpark, obviously you should know about PySpark. If you know about PySpark, now you just need a kind of quick overview of pandas. Like you just want to go through the functions, because the syntax is almost similar, not very different, and data frames are data frames, so that is why it is like pretty much similar. But still, you can just go on any browser and just simply search, let's say pandas cheat sheet, and there will be like so many websites that have like pandas cheat sheet. So many, they even have their official pandas cheat sheet PDF as well from pandas.pydata.org. So they have like all the functions written here, which will be very handy. This is not very long, just 2 to 3 pages. And I will say 2 pages because the third page is just for the visualization if you want to visualize something. Make sense? Okay, very good. So now let's say this is my DF. Okay, you can perform some transformations using that cheat sheet. So let me quickly bring only one transformation, very basic, very simple. Let's say I want to filter my data. So in order to filter this data, I can simply run this code, which will bring all the records which have payment method equals to card. That's it. Let's see. See, this has brought that records who have the payment method equals to card. Make sense? Okay, good. So now this is my data frame. Okay, simple. This is my data frame. So now here I can just perform more and more transformations, and obviously this is not like end-to-end pandas masterclass. This is just like glimpse of pandas. And if you want me to create a dedicated video on pandas, I can, just do let me know in the comment section. But what do I feel? If you already know PySpark, if you already know how to work with PySpark transformations, you do not actually need a pandas data frame or basically pandas masterclass, because you can easily use pandas transformations using any cheat sheet. That's it. You do not need a dedicated video, but if you need, do let me know. This boy will just make that video for you, so no need to worry. Okay, so far so good. We can actually work with so many visualization libraries as well, such as matplotlib. So if you just go to this cheat sheet, you will find these kinds of thing, df.plot, which will help you to just plot some things. Okay, then let me just check the package to import. I know it's like matplotlib. So let's import from matplotlib, import pyplot as plt. Okay, and now let's try to build something. Let's say I want to see the histogram for the sales amount, which is like a kind of statistical insights that I want to see. So what it will do, matplotlib is not installed, obviously. Let me just add it. Pip installed matplotlib. This is like one of the best thing about Pandas library that you can visualize the data at the same time. But when you use software such as Databricks, they already have that capabilities to let you build your charts, so it's not a big deal. Okay, but yes, you should know about these things. You are a data professional, so whenever we talk about data frames, we should know about all the types of data frames that we can just work with. Obviously, we do not have sales amount here, we have gross amount. Okay, so this has given me an amazing histogram within my notebook. Okay, with this just like one line of code. So this way you can just build a lot of things. By the way, what this histogram is saying, this is saying like, hey, 0 to I think 100, we have these kinds of values, and this is like obviously not normalized. It's very skewed. So that's how you can just make sure like what is the statistical picture of your data. Okay, so obviously if you are a data engineer, that means you know how to work with big data, and you are automatically serving a role of big data analyst as well, where you know like some things, how to analyze the data as well, a little bit of it, because you are not blind, you're not dumb that you do not even know anything about data. You should know about data, a little bit of it. Okay, perfect. So this way you have so many functions. By the way, you can just play with it. You have pie chart and all, so many things. Myself I also have not worked with a lot with Pandas, obviously. So even if you do not know much about Pandas, it's fine, but just explore, just for the knowledge. If let's say someone is asking you about anything about Pandas, you should not behave like you do not know anything. You can say like, yeah, I'm a data engineer and I know a little bit about Pandas. It's pretty much similar to PySpark. I can literally perform anything with PySpark that I do not need to perform with Pandas, because we work with clusters, we work with big data, we work with distributed computing. So obviously we work with big data. So that's fine. But you should know a little bit about Pandas. You should not behave like dumb. Hey, what is this Pandas? Is it an animal or a library? So do not make an answer like this. Right. Okay, sorted. So this is all about this thing. So let's say now we want to write our data. Okay, how we can just write the data? It is very simple. You can simply say df dot. Okay, and let's say you want to write this data like this. So it will create a CSV file here. It's called filtered sales.csv. Simple, very good. So this is like one notebook which is called basics, and this exact notebook is this one which is called basics. Okay, the same notebook is here, and without obviously visualization, but I just added this as well. Special touch, and let me just remove this as well. So now we're gonna talk about an advanced topic which is called combining Delta Lake with Pandas. You will say, hey, what? Delta Lake with Pandas? Yes. So far, you would be hearing that we work with Delta Lake with Apache Spark, right? But Delta Lake is compatible with Pandas data frame as well. Yes, you can work with Pandas if you want to work with Delta Lake. If your data size is not much big enough, if you do not want to perform, let's say, upserts, obviously you can perform upserts with Pandas as well, but you need to write a custom logic for it. But yes, when you just want to perform lightweight processing with Delta Lake, you can go with Pandas as well. Okay, because let's say you want to store your data, right? So instead of just using servers, SQL servers, where you just need to connect to the server, connections, managing all those things, so you can just simply use Delta Lake, because Delta Lake is equivalent to a proper database because it supports ACID properties. Again, this is not a Delta Lake masterclass. If you need to know about Delta Lake, which you should, you can simply go on any browser and simply search Delta Lake Anshlambacollab. Okay, and this is the video that you can just watch, Delta Lake 4.0 full course. And this is literally one of the best Delta Lake full course from scratch. If you do not have any kind of experience, any knowledge, nothing, this video is for you. And this video will actually make you a pro Delta Lake developer. There are basically two videos. One is this one. So this one was for like previous version, and 4.0 is the latest version. So you can just watch any video. I will recommend to watch this video. Okay, Delta Lake is the need of the hour for data engineers, and it is better than Apache Iceberg and Hoodie. So obviously Delta Lake is amazing. So just be familiar with that particular, you can say, modular package. Okay, very good. So now let's see like how we can just work with Delta Lake with Pandas. Let me just show you a very good blog that you can also read. Pandas data frame with Delta Lake. Perfect. So if I find it, I think this is the one. Yeah. So this is a blog, like official blog by Delta Lake. So it is written like how you can just connect the Delta Lake with your Pandas data frame. And obviously you need to just download or basically install Delta Lake module. Okay. In my case, I've already done that. Let me just redo for you. Pip install Delta Lake. So you can also do that. Okay. Perfect. So once you do that, it will download all the dependencies, all the packages that are necessary to perform any Delta Lake operation, right? So very simple, very simple. Let's say you want to read this file, okay, and you want to write this data in the Delta format, and then you want to read that Delta table, basically Delta data. So this notebook is like step-by-step guide. Let me just first of all run the cell one by one. So this is one. And this is simple, you can say format that you have also seen, okay, how we can just read the data. So now what we can do, we can simply import these two packages, Delta table and write Delta Lake. Simply run this, and then you can write this particular data frame in this particular folder that it will create automatically. Let me just run this and you will see this folder ready. It's called sales Delta table. So it has created that folder for me. And now if I just open this folder, I will see my Delta data sitting here. I can see one Parquet file. I can see my Delta log as well. Make sense? And obviously in the Delta log, you will see JSON, right? Like this. Wow. Literally wow. All the transactions are here. All the transactions. So this way you can actually write your data in the Delta format using Pandas library. Okay. Now let's say you want to read this data, which is sitting in the Delta format. Very simple. Simply run this and it will read the data for you. Basically, it will convert this data frame, basically this Delta object into Pandas, and that's it. Make sense? Make sense? Make sense? That's all about your Delta Lake with Pandas. And now let's talk about this masterclass. How was it? I hope that you have learned all these areas because the thing is, when I was just about to create this video, I was thinking like all these areas are actually missing. Not missing, there was a gap. So I thought of like, let's add these things in our industry and let's provide this knowledge to my lovely data fam so that they can just grow in their career. They can stand out in the crowd. I know the world is like really competitive right now, but it's my responsibility to help you guys because see, I am also a learner. Okay. I'm just sharing some things with you. That's it. So that you can grow in your career. And now I need your help to grow this channel, to grow this community. Why? Because I want to help maximum number of people. And I also want to bring that smile on their faces, on their family member faces, or on their loved ones' faces. So that, see, you need to support this channel. Only then this channel will be just reaching to the larger number of audience, right? I know that you also want to just bring smile on other people's faces, and now you can just do it like, see, your one like one click on like button, one click on comment button, one click on subscribe button, one click on share button actually helps you. I don't know if you realize it or not, but you are actually helping to grow this community. And I know you love me a lot. I know that. So let's grow this community together. Let's try to help others and let's try to make data engineering, AI data engineering affordable so that they can learn, like everyone can learn and grow in their career, right? Right? Okay. So that's all about today's masterclass. And I loved recording this video. I loved recording this particular masterclass. And I hope you also loved it. Just share this video with maximum number of people on every platform and see you in the next video coming on the screen right now. Happy learning.